or remember what we have done. We did go through virtual machines again, but in little more detail about
A-
the
a-
yes,
Azure Bastion and
Bastion, yes.
RDP, yeah, and
What
VPN.
virtual
How to?
machines and how to connect to the virtual machines.
Yes.
Direct with the native access tools like RDP and SSH for Windows for RDP for Windows and SSH for Linux machine. And we have also seen how we can use Bastion host or the Bastion service to securely access our virtual machines, right? So let's continue from there. We have a lab to start with. We Let me share the screen. What lab we are going to do? So the purpose of doing the labs in the live sessions is to see everything whatever you're learning to implement and feel it in practicals. So that really shows you whatever you have discussed, whatever we discussed or studied in theory is actually applicable and practically possible to implement. So let me bring up the lab which we have to do today. I'm just going to open the link. Did anyone get the chance to do any labs? I guess no. So at least this is a chance for you to see it in practicals in the demos. Later you can do it yourself, of course. So let's go to the virtual machines lab number 8. You can see that we have skipped many labs: implement inter-site connectivity, implement network traffic management, and there are labs in we have another topic, storage, which we'll be covering later. So I'm keeping those labs for later because there are few topics which I have not discussed, and those are advanced topics. So I felt that it will be easier for us to do those labs after completing this virtual machine topic. So I'm going to this lab. So remember we have discussed virtual machine scale set, uh, availability set, and the scale set. These are two different things, right? Now availability set, as you know, we can when we are deploying the virtual machines, it makes sure that the virtual machine is deployed in multiple virtual. If you are deploying mainly, it's mainly applicable for more than one virtual machine, right? I'm going to share the screen again from the whiteboard. Let me explain you little bit on the whiteboard. So in the lab what we are going to do, right? Okay, so start with the blackboard, right? Got it. So we have seen there are two things here. Uh, we have availability set and we have scale set. Both are similar concepts, but there are different ways of implementing it. So again, as I told you, availability set, it applies for more than one machine. It's only option. This option is only available and it's applicable when you are deploying more than one machine, more than one VM, right? I've given you the scenario. Why would you go for availability set if you are deploying a highly available application, let's say a web server, right? So you want high availability for your web server. So you might be deploying more than one web server in order to make sure that your service is highly available. So you're deploying these two virtual machines. These are nothing but virtual machines. But while deploying, you want to make sure that these virtual machines are deployed on different fault domains and the update domains, right? So we have seen what is the fault domain and what is the update domain. So this is a fault domain, FD, and within a fault domain, you have update domains, which is nothing but a server in a cabinet, you can say. Right? Those who has not seen uh, in practicals what exactly the server looks like, I have few screenshots which I'll show you quickly. Let me share the full screen because I'm sharing a window and you're not able to see it. Where is the sharing option? Right. So you see what is this? This is nothing but a cabinet you can see on in which uh, there is a chassis enclosure and it has servers. This this one of these each of this the component is nothing but a server. This is a blade server. There's a concept of blade server. You get server in different forms. This is one of the type you can have, and you can see here. This is the enclosure with multiple servers. You can see 9 servers, 18 servers in one enclosure. So either you get servers, physical hardware in this form, or you also get in this form, which is also called as a rack mountable server or a brick server. So that's how that's physically how it looks like. You can see this. This is another image which gives you a visuals how the server is installed in the cabinet, right? And this is nothing but a cabinet. So these are the cabinets. Now you call this component a cabinet as well as the rack, where you're racking your server storage and network equipment. So these are multiple cabinets you can see, which are fully populated, either servers or the network devices or the storage units. All goes in here in the data center, right? So that's just a simple, the images which explains you what in reality the server looks like. And there was a storage picture as well. Let me see now this one. This looks like a storage, physical storage, which is mounted on the in a cabinet. You can see there are multiple hard drives. These are the storage enclosures with all these hard drives connected. So this you can configure this whole storage, all of these units as a single storage unit, and you can create the partitions like we do on our PCs. If you have multiple hard drives, you can configure RAID and logically use all the drives capacity as one drive. So this is how the storage looks like. So all of this in Azure cloud behind the scenes is going to be like this. The servers, cabinets, servers, storage units, network devices, and so on. Right. So just have that in your imagination when we are discussing all the Azure components. So yeah, I'm going back to the whiteboard. Mm. Okay, so we were discussing about availability set. So what happens is when you're deploying a virtual machine, you have seen when you deploy a single virtual machine, you don't get an option of availability set. But when you deploy, now how do we do this? How do we configure the availability set? That I'll show you in the Azure portal. Let me go back to the lab, to the Azure portal. I'll share it. Again, when it comes to load balancing the services, this is one of the scenario wherein you can use availability set and deploy your virtual machines. Make sure that your virtual machines are deployed across multiple fault domains and the update domain. There is a scale set which is a preferred way of doing for high availability. Are you able to see the screen? I'm sharing now from the other screen. So I'm on the portal now.
Yes.
Yeah. So what I'm going to do is I'm going to create an availability set. Now, based on my requirement, what I need is a, availability set for my web servers. So let me get rid of this one, or we can just delete this or leave this as I'm creating an availability set. See, when you're creating an availability set, you have two options here. Uh, just an availability set itself, or you have an option to create virtual machine scale set. So these both the concepts are similar. The difference is that in availability set, you have to manually create the virtual machines, multiple virtual machines. And the scale set, it will automatically create the virtual machines based on your compute requirement. So what happens is that it will do the scaling. This is good for auto scaling. We have seen the scaling options, right? You can do the scale up or scale out. So either you can increase the resources on on an existing virtual machine, or you can add up new virtual machines to the scale set group. So we are going to look at availability set for now. I'm just going to create an availability set. Now, what does it, what are the parameters here? Again, you have to select the subscription. You have to select the resource group, the correct resource group where you want to create it. And then I'm going to name it web AV set. So it's just a name. You can use any name. I'm using this to represent as a group of virtual web servers. So this is going to be my availability set. Now here you have an option again, the region is the mandatory field. You have to select the region. You have two options here, fault domains and update domains. So you can go maximum 3 fault domains. That means, what does it mean here? When we saw it on the whiteboard, 3 fault domains means 3 different cabinets or the racks. So when you create the virtual machines which are part of this availability set, they will be deployed. It will make sure the in the background that your virtual machine is placed in a different fault domain, not on the same fault domain. So let's keep it default. By default, it is 2, and it really matters how many VMs you're creating in one availability set. So review and create. There's nothing much. You can see there's not much configuration in creating the availability set itself, because it's just the configuration what you're doing here. But you have not done any VMs, you have not connected any VMs to this availability set. So I'll go to the whiteboard. I'll show you the process. Let's create this, then I'll show you the explain it on the whiteboard. The availability set will be created here, and it is created, right? So that's the configuration. What we have done. There's not much configuration in the availability set by itself. Now, when you create the virtual machine, let's go back to our previous exercise where we have created the virtual machines. And you have, when you're creating the virtual machine, you can see there are different options available. We have so far just seen how to create the virtual machine. In the next exercise, we'll be seeing how to create the virtual machine scale set. Why is it required? When it is used, it gives you a very brief description here. Built-in scaling, performance optimization, load balancing, and batch management for 1 to 1000 VMs, no added cost. Include multiple VM sizes, zones, regions, and domains along with discounted spot VMs. We have not seen what is the spot VM. We'll discuss that later. But what it is telling you is that it will create a virtual machine skill set, and it can scale up to 1000 virtual machines, and those will be deployed across the region, across a particular region where you're deploying the virtual machine. So it will make sure not just the fault domain. If you have if you are creating 3 virtual machine and as part of the skill set, so what it does is it makes sure that your virtual machine is distributed across different data centers, not just a different rack or a cabinet within the data center. That's the advantage of doing this. Presets, we have not looked at presets, and we have not even seen hybrid pre-configured high volume solution. So we are now going to create just a simple VM just to see how the availability set is created. So while creating the virtual machine, now I choose my resource group. I have to give the machine name IBM1. For example, I'm not going through the whole process. I'm just trying to show you where you see that availability set which you have created. Now, availability options. Now here you can see you have no infrastructure redundancy required. You have availability zones. So that what does it mean? It means physically separate your resources within an Azure region. That means when you're creating the virtual machine and choosing availability zone as an option for redundancy, it will make sure that the virtual machine is deployed in different region within the same region in a different data center. Virtual machine scale set. This is the auto scaling option which we have to see in the next lab. Availability set automatically distributes your VMs across multiple folders. This is what we are referring to now. So this is where you see you set availability set, and now where is the availability set which we created? Availability set is here. You can see this is my availability set. Web AV set. This is what I have created before creating the VMs. So you have to make sure that you have the availability set created. Either you can do it beforehand or you can create it right at the time of creating the virtual machine. So now this is how I relate my virtual machine to an availability set and create the virtual machine. Same as the virtual machine creation process, exactly the same what we have done before. I'm going back to the whiteboard to explain you. So what will happen? What is the process of doing this? Okay, right. So whiteboard is still loading. Okay. So what is the process? Now, in order to create this availability set, first you create the availability set, AV set. Okay. Second, you create virtual machines. So I'm going to deploy two web servers. So create your VM W1. So while creating the virtual machine, the first virtual machine, you are going to link it to the availability set, AVSet web, what you have created here, right? So this is how you'll do it. And number three, step three will be you will create one more VM and you'll name it web2. And again, you'll relate it to the AVSet web. So the point to remember here is that you're just with the help of availability set, you're just making sure that your virtual machine, the one with the name web uh, W1 is deployed here, and the other one is deployed in here. Though you don't have an option to choose on which rack, which fault domain it goes to, but and behind the scene, this is what Azure is doing. So you're simply creating a AV set. In the AV set, while creating the virtual machines, you are relating your virtual machine to that particular AV set. And in the background, Azure is making sure that your virtual machine Web1 and Web2, the W1 and W2 are deployed in two separate fault domains. I hope that is clear. That is the availability set, right? Now, let's continue with the scale set. We have the lab now. The scale set, as I told you, it's basically for scaling, and that is auto scaling. So next thing is that we'll create the scale set. So again, the concept is same. In availability set, you are manually configuring the availability set and telling the VMs to be deployed in different cabinets and different fault domains. In availability set, in scale set, you will create a virtual machine, okay, VM1. And when you create the virtual machine VM2, or you don't have to really create a second virtual machine, it will be automatically created. So if you enable auto scaling, auto scale, your virtual machine will be, the second virtual machine will be automatically created based on the condition which is set for scaling. So if the virtual machine one is going above the threshold, you have set the threshold 75% of the CPU utilization. So based on those conditions, it will automatically go ahead and create the scale set. So I'm now we have the lab for the scale set. We'll see how this is going to work. Okay, I'm going to the lab now. Let's go through the lab. Right. So in this lab, what are we going to do? There are you need to understand the lab. What exactly we just don't want to click step by step process and complete the lab. We want to understand the task. What is the task assigned to us? In this lab, you create and compare virtual machines to virtual machine scale sets. Okay, that's fine. So you learn how to create, configure, and resize a single virtual machine. That's one of the exercise we have. Until now, we have just seen that how to create the virtual machine. We have not seen how to resize it. The moment after the VM is created, how you can manually resize the virtual machine. So we'll be seeing that as well here. You learn how to create a virtual machine scale set and configure auto scaling. This is what this lab is all about. So scale set, how we can configure the scale set and how we can activate the auto scaling. Right, this lab requires Azure subscription, we know that, and it takes around 50 minutes, depending on our speed of doing this lab. We don't want to speed up and hurry up. We need to make sure that we understand what we're doing. So the lab scenario is like this. Your organization wants to explore deploying and configuring Azure virtual machines. First, you implement an Azure virtual machine with manual scaling. We can see how we can set up the manual scaling. Next, you can implement a virtual machine scale set and explore auto scaling, right? So these are the advantages of running your workloads or the virtual machines on the cloud. So you have these features wherein you can auto scale the virtual machine based on the demand. So job skills, now we have the task, very specific task defined here. Task one, deploy zone resilient Azure virtual machines by using Azure Portal. Zone resilient, that means the virtual machine you can deploy in different zones. And then we manage compute and storage scaling for virtual machine. In the task three, we create, configure virtual machine scale sets. Task four, scale Azure virtual machine scale set. And then task five, create virtual machine using the PowerShell. This is optional. We have already seen this, but we can run through this again for your understanding. So this is the scenario here, Azure virtual machine architecture diagram. And the task one, what are we going to do? We are going to create VM1, VM2, two VMs we are creating. And no, sorry, that's a task one, two VMs, yes. And you see, observe the difference here. We're deploying VM1 in zone 1 and VM2 in zone 2. What does it mean? The zone is nothing but a data center. We are placing these virtual machines in two different data centers. Although we don't have a choice to choose which data center physically, but within an Azure zone, availability zone, you might have more than one data centers. So Azure in the background, it will make sure that your VM is deployed on a specific zone, specific data center. Task two is resize and update. We'll see how we can resize the virtual machine and update the virtual machine. So let's continue with this task. Deploying the first task. In this task, you will deploy two virtual machines into different availability zones by using the Azure portal. Availability zones offer the highest level of uptime SLA for virtual machines. That's 99.99% availability, right? This is something which the cloud computing is very popular for, making sure that your services are available, highly available in case of disasters. To achieve this SLA, you must even though having so many features and what do you say, the technologies to making sure that your data center is available, your cloud is available. We have seen in the past, recent past, there have been multiple instances where cloud service providers data centers have gone down due to technical issues and so on. So that it's a good uh, it's a good time for you guys to understand, to read through those incidents which are occurring on the cloud computing platforms. So it gives you a bit of background and explains you what is happening. So, and you will be able to understand and relate to whatever you're discussing here. So you should go through the RCA, that means root cause analysis. Recently, AWS cloud service was down. That means anyone who were hosting their applications on the AWS cloud, all those applications were not accessible. And that really comes down to the business impact. So there were losses reported by the customers, and Azure or the AWS, your cloud service provider, is bound to pay you for those losses based on the SLAs what they are offering, right? So to achieve this SLA, you must deploy at least two virtual machines across different availability zones, right? So we are going to the Azure portal. Now we are going to the virtual machine. We have already done that. Let's do that again. But this time we are going to place the virtual machines in two different availability zones. Okay, so virtual machine, on the virtual machine, click create Azure virtual machine. We know this process already. On the basics tab in the availability zone drop down menu, let's go to that particular task. So I'm going to use my existing resource group. Is it giving you the option to create the resource group or use the IPs? No, let's see. Okay, on basics tab in the availability zone drop down. Okay, it's going straight over to this. Right. Let's go to the step 3 on the basics tab, availability zone drop down menu. Place a check mark next to the zone 2. This should select both zone 1 and zone 2. Basics tab. Where is the basics tab? Availability zone. The availability zone. Let's go to the availability zone. Okay, so here you have availability zone, right? So here you can see that you can create your virtual machine. You can choose the zones here. So what we are going to do, we are going to choose zone 2 for this virtual machine. We are creating in zone 2. What does it mean here? Now we are in which region? Which we are in East US region, and this actually tells you that in East US region there are three physically separate data centers which Microsoft is operating within the close proximity, right? So the zone is nothing but a data center here. That's literally what it means for you to understand. Okay, so next to zone 2, this should select both zone 1 and zone 2. So we should have zone 1 and zone 2 both selected. So it gives you a message here. Based on your zone selection, we'll place two virtual machines, one in each selected zone, right? You may want to create this resource as a virtual machine scale set instead, which allows you to manage, configure, and scale load balance virtual machines. So now what we're doing, we are manually creating a virtual machine, and that virtual machine, for that virtual machine, we are selecting two zones. So with this option, it is going to create two copies of the virtual machine, and that virtual machine will be deployed in each of these zones, each data center. The two data centers, we are deploying this particular virtual machine. So it is giving you the information that instead of doing this, you can go ahead and consider using the virtual machine scale set, which gives you more flexibility and scalability. So we'll see that we are just doing this as part of the exercise. So we will also see that. So this will, there's a note here again. This will deploy two virtual machines in the selected region, one in each zone, and you achieve the 99.99% uptime SLA because you have at least two VMs distributed across at least two zones, right? The zone is nothing but a data center. In this scenario, where you might only need one VM, it is the best practice to still deploy the VM to another zone. Right, let's carry on with this exercise. So I'm going to create the name of your Azure subscription. Okay, we are going back to the basics. That's the subscription, and this is the resource group name, which I'm using, and virtual machine names. So I'm going to select this name. Sorry, AZ, that's my virtual machine name. So you can see that it is creating automatically because you have selected two zones, and it's automatically going to create two virtual machines, and it has also decided what to name those virtual machines. My VM1, my VM2. So it is Azure, which is doing it in the background. So now we are going to create it, the names based on this exercise. I'm going to use let me name it edit names. Yes. So we name it here. Sorry, edit names. I hope you guys are following me, right? Because sometimes I feel I'm just talking to myself. So just follow and stop me wherever you have any doubt. If you feel that there's something which you need to understand, I'll stop right there and explain you, because I'm reading through the lab exercise notes specifically because you need to understand what exactly you're doing here. Right? So now what I've done, I've given the names for my virtual machines. There'll be two virtual machines created. That's because I have selected multiple zones. So we are going to deploy these virtual machines in each zone, and we are going to choose availability zones. We have done that already. Zone 1 and zone 2. Security type, we are going to leave it as standard for now. Going back, security type is going to be standard. We have not seen what those security features are, and that's not part of this lab as of now. And the image, we are going to deploy a Windows Server 2019 data center edition. So Windows Server, I guess Windows Server 2019 is already out of support. So that's why we don't see the Windows Server 2019 here anymore. We'll go ahead and deploy data center 2025 data center operating system. Okay. So that's the image we're going to use. Azure Spot instance is unchecked. We have not discussed what is the Spot instance. We'll not discuss it right now. Okay, let's go ahead with this. And the size is D2SV3. Size of the VM is going to be this. So this will deploy a virtual machine with two virtual CPUs, 8 gig memory. And the username, you can create anything. I prefer to use Azure admin as a username. And the password, I'm going to set the password, Azure 23. Okay, and confirm the password. Okay, provide secure password, and then public endpoints none, ports none. We are not enabling the access to these virtual machines over the internet. Would you like to use existing Windows license is unchecked. So yes, it's unchecked. This applies when you have your license from Microsoft already. You're having Windows servers running on-prem scenario, so you can make use of same license when deploying a virtual machine on the cloud. Right. So we have we reached till here. So now it looks like based on the number of availability zones selected, two virtual machines will be created. The following setting will be applied to each virtual machine unless specified otherwise. So now it is telling you for each virtual machine what is the configuration will be applicable. So the VM name, yes, it has to be unique because you can't have the two virtual machines running with the same name. It has created and suggested you to create two virtual machines with the different names. And we have selected the region, we have selected availability zone, and we are deploying these virtual machines in two different roles. Until now, the exercise of VM creation, we have seen only deploying a virtual machine which is in a single zone, which is not a highly available redundant virtual machine. Now, this we are going to do for a specific reason for this task to be seen in practicals. Security type standard image is this, and thus with this we go to the next step. Step number 5. Next is the disk allocation. And here, what are we going to do? OS disk is going to be premium SSD. Operating system disk is premium SSD already, and it's just premium SSD. So we have an option here, premium SSD, and that's already selected. Now we have premium SSD option. Zone redundant. Does it say about the zone here? Doesn't show. Okay, so let's keep the premium SSD default setting. Delete with VM checked default. By default, I've explained you. Why would you want to keep the virtual hard disk? When you delete the virtual machine, if you want to retain the hard disk itself in order to rebuild that virtual machine later on, you can easily do that. Go to the networking tab now. You're going to the networking. Okay. And in here, what do we have? Delete public IP and NIC when VM is deleted. So we are selecting delete public IP. Okay. Delete public IP and the NIC when VM is deleted. So NIC is nothing but a network interface card. So we have seen when we create a VM virtual machine, there is a network interface card is also created with it, which provides a connectivity for that virtual machine to the network. Okay, that is checked. Load balancing option none. We have not discussed about the load balancing yet. We'll see that later. We are going to say none. Okay, here we are going through many different options now. Okay, go to the next management tab. So you can see that for a simple virtual machine, you have so many options to choose from. You can based on your requirement again. So we're going to the net management and review settings. Do not make any changes. We're not going to make any changes here. You can see what you have here. You have an auto shutdown enable auto shutdown, and there's a shutdown time. So if your VMs are not required to run in the night time, this would be a good idea to shut down the virtual machine when not in use. So if it is a development environment, you know that your developers work only during the daytime from 9 to 5 or 9 to 6. And after that, you can set your virtual machines to shut down itself. Because if you keep the virtual machine running, you will be built for all the time which you'll be, you'll not be utilizing it for. So it's a good idea and good practice to keep it shut down. And we are going to do that. And notification before shutdown, you can enable the notification. You can define your email address when the VM is shut down. And enable backup. We have not seen the backup yet. We'll see it in the next classes, how we can back up the virtual machine. Guest OS updates, enable periodic assessment, and enable hot patch. So these are the options for you. Your VM is nothing but a guest operating system, right? It's a guest on the host. So host is the physical server, which I have explained you yesterday, and guest is the virtual machine which you're running. So how you want to update this? You have different options here. You can do the automatic OS updates on those virtual machines, and we are not going to look into all those options now. We are going to go, and in the next one, monitoring tab. In the next monitoring tab, we have an option. We are selecting boot diagnostics. Disable should be disabled. Boot diagnostics should be disabled. Okay, it's disabled. Now we go to the next one, advanced tab, and here we are just going to review and create it. Review and create the virtual machine. So what's going to happen now? In the background, let's see if the validation passes here. If there is an issue with this deployment, it will alert you, and the validation is passed. So we are good to go. So it is going to deploy 2 into standard D series V3 virtual machine, right? And it is going to cost you this much per hour. Okay, the price for the size of VM which you have selected. And here you can see the details. It is creating 2 virtual machines with these names. This is your virtual machine name, VM1 and VM2. And it's also going to have the public IPs assigned, but we are not going to use it. This is the subscription resource group, ECUS, availability zone, self-selected zone. We have selected the zones 1 and 2. It's going to be a standard security type and all the details which you have selected during the creation process, right? So let's go ahead and create this one. This might take a time because we are deploying in this process, we are deploying 2 virtual machines in 2 different data centers, the zones. So notice as the virtual machines deploy, the NIC, disk, and the public IP addresses, if configured, are independently created and manage resources. So this is a note for you, which I've already explained to you that when you create a virtual machine, it creates all the supporting components along with it. And each of these resource can be managed separately. The network interface card, the disk, and the IP address. Just like your home PC, you have the home PC. Once you install and build your home PC, install the operating system, you have an option to attach a network interface card, right? It really depends if you want to use that virtual machine for accessing internet or accessing other network machines in your home. So you can choose those options. Excuse me for a minute. Sorry for the disruption. Okay. So what I was explaining is that, I was just giving an example of your home PC. Like when you build your home PC, it's up to you whether you want to have an additional disk assigned to it or additional virtual machine assigned to it, right? So it's up. So you can independently manage those components in Azure as well. You have an option to create the network interface card separately and attach to the virtual machine as well. So now let's proceed. We should be having the virtual machines deployed by now, right? Let's go to the virtual machines now and let's see. So our resource group, sorry, that's not our resource group. This is our resource group. Okay, in this resource group, you can see, like, so what all virtual machines are created here. We have two virtual machines. Let's see. Where's the virtual machine? I don't see it. Okay, here. You can see these are the two virtual machines which are created in different zones. It's within the same region, but it should be deployed in different zones. So we can go and check the details. VM1 this is deployed in zone 1, and if you go to okay, VM2, you can see that it's deployed in zone 2. So this is all done in the behind the scenes. So you have two virtual machines created, and this is what I was telling you. For each virtual machine, what all it has created. For example, this one, and see it here, but it will be easier to see in the resource group itself. Right. Let's see. So you can see it creates a virtual machine, and it also creates the supporting components with the same name as virtual machine. So it has created a public IP address, but it is following the same naming convention so that you know that this IP address, this component is belongs to this virtual machine. So it just adds the prefix, suffix to it. So you can see the virtual machine VM1 IP address, NSG. It creates a network security group also. It creates a network interface card for the VM1 with the this suffix, and you can see there are two virtual network interface cards created for it, and there is a hard disk also created for the virtual machine. So we have seen yesterday when you create a virtual machine, how many disks are created with the virtual machine? That's a question to you guys now. Anyone? I just need someone to answer me this question. When you're creating a virtual machine, how many disks are created for that virtual machine?
Three.
Sorry,
Three.
three?
Yeah. One is
Okay.
temp disk.
Uh-huh.
One is data disk.
Mm-hmm.
One is I think OS disk.
Are you sure?
Mm.
Shall I lock it?
Not sure, but
Anyone
No,
else?
OS disk is created with the VM, but data
I
disk,
my question is simple. How many disks are created when you create a virtual machine?
I think OS disk only.
You think
only one.
only one? Okay.
Only
Yes.
one.
I have
Only one.
okay. Both the answers are wrong. Anyone who can give me the correct answer? If not, I'll explain you. Both the answers are wrong. I've given you the very simple explanation yesterday with the slides showing you the moment you create the virtual machine, there are two disks created. Only
Temp and
two.
OS. Yeah, temp and
Operating
OS.
system disk and the temporary disk.
Yes, yes.
And even
But
temporary disk is optional because that really depends on the virtual machine size. So some VM sizes doesn't have the temporary disk created with itself. So data disk is something which you optionally can create later on. So if you want additional storage for your server or your virtual machine, you can add that later. But the moment you create the virtual machine, OS disk is created for sure because without that, your VM will not boot and run the operating system. Clear?
yes, clear.
Right. And you don't see the temp disk here in the resources because that's by nature it's temporary. Even though it is created for the VM, when you log into the server, you can see there's a D drive created and there's a temp which is used for temporary storage. Okay. All right. Let's continue with our exercise. So now task two, manage compute and storage scaling for virtual machines. So what are we going to do with this now? In this task, you will scale a virtual machine by adjusting its size to a different SKU, right? So you know what is SKU or SKU means in virtual machines. Uh, every virtual machine comes with different parameters, size, storage size, virtual machine, virtual CPUs, and the RAM. So Azure provides flexibility in VM size selection so that you can adjust a VM for periods of time if it needs more or less compute and memory allocated, right? So you can adjust this manually. This concept is extended to disks where you can modify the performance of the disk or increase the allocated capacity. So this you can basically upsize your virtual machine. Now compare this with your physical server. Let's say you have bought a physical server for your organization on-prem scenario. You bought a server with eight CPUs and 16 GB RAM, right? And you have the server running for the organization for last 1 year. Suddenly, there's a requirement from the business that the server has to be upgraded. There's a particular application which needs at least 32 GB RAM to run and 16 CPUs as a processing power. So what would you do in that scenario? It is not really straightforward and forward and handy to upgrade a server with to double the capacity, right? There is a separate process. First of all, you have to look at the server which you have bought, whether it supports that much RAM, doubling the RAM from 16 to 32 GB. because you're fixed with the hardware, right? You're limited with the hardware, which and the support it and the devices it support, the capacity it support. You can't really upscale the CPUs. Let's say it has it maximum the support of the this server which you have bought is 16 CPU, 8 CPUs only. You can't add six more to it. So those are the limitations where you will face when you go with physical servers and when you have your servers on-prem deployed. Now, comparing that, yes, of course, if you have the virtualization again on-prem, you have a bigger capacity of physical servers. Virtual machines you can scale up similarly as you can do in Azure. So it's very easy in Azure. But again, here again on-prem, you will have a set limit. You can't really go with very big capacity. In Azure, Microsoft is taking care of this in the background. Based on the demand and the request, what your request, they scale up easily in because they have they do their analytics and they do the sizing. They predict the size requirement for the customers, how many customers they might expect, and how many virtual CPUs they might require. So there's a prediction. They keep constantly updating and upgrading their hardware as well in the background. But that's something which you don't have to worry about when you go with the virtual machines. So right, we are going to the virtual machine VM1 now in the portal, virtual machine VM1, and in the availability set, blade, where is the availability set? Okay, in the availability set plus scale blade, click on the size. So we go to the size. So now we are changing our size, the virtual machine size. Earlier it was V3, version 3 in D series system. So now we are going to a different size. This was our current size, D2S V3. Now we are going to change it to DS V4. Sorry, D2 DS V4. So you can look for it or you can search for it, I think. Yeah, we can do the search as well.
Excuse me, sir.
Yes, go ahead.
Yeah, we are now increasing the scale in, sir. So
We are
they will
doing,
charge
yeah,
for that, sir.
yes,
Like
it will
for
be charged. So there'll be a different price again. You'll end up paying for this virtual machine. The price
okay,
will
sir.
increase, of course.
Now we are for the lab test. It's we will take the free one, is it, sir?
I'm just going with whatever it is showing in the lab.
Okay, okay,
We are going ahead with the D2 DSV4. So just for the sake of lab, we are doing it.
okay, okay,
So
sir.
I'm going to resize it now. Okay, so what does it say? Resize this virtual machine. Do you want to resize to size this? If the virtual machine is currently running, changing its size will cause it to be restarted. So you have to note that. And if you are having any critical application running, first you have to make sure that you have a change window or the maintenance window approved from your business, and you can go ahead and do the resizing. So we are going to resize. Choose another size if this size is not available in the region. Okay, so you can now it also has a note here. Resizing is also known as vertical scaling, up or down, right? So we have seen scaling options, right? Vertical scaling and horizontal scaling. Now we are doing vertical scaling. That means we are adding up the resources to the existing virtual machine, right? So let's go ahead and resize. Okay, so it will cause the VM to restart, reboot for resizing. Let it do that. So we'll continue with the lab here. So after the resizing, we go to the settings and select disk. Once the resizing is done, so now we are managing the virtual machine settings. So all the settings which you're seeing here on the left side plate, these are all specific settings for this specific virtual machine. So we are right now we are just resizing one particular virtual machine, and the manually we are scaling up the resources. So we are doing a vertical scaling scale up here. So okay, in the settings area, we are going to the disk. So in the settings, we have the disk here. Rescaling is still going on. Now under the data disk, select create and attach a new disk. So after the resizing of the virtual machine, what we are going to do now, we are going to create a new disk. Now we are assigning a additional disk to our virtual machine, right? This is what I've explained yesterday. So if you have a VM which will have the OS disk created automatically and the temporary disk created, if you need an additional disk, you can create and assign that additional disk to the virtual machine. And it's a best practice that you should always have your application installed and saved in a different disk than the operating system. Okay, under data, just select create and attach a new disk. So we have to wait because this process is basically going to reboot the virtual machine, resizing, and we'll see that. So we are going to create a VM disk one, and it's going to be a standard HDD hard disk drive, and the size of the virtual hard disk is going to be 32 GB. And click apply. After the disk has been created, click detach. If necessary, scroll down to the right view. Okay, we are creating a disk and detaching it. That means detaching removes the disk from the VM, but keeps it in storage for later use. You understand what we are doing here? Does everyone understand what does this mean? So we are creating an additional disk on this VM. Because we are doing this on the VM and on the VM1. So it is going ahead and creating a virtual disk for it. But after creating the virtual disk, we are detaching it. That means you are separating. Uh, Again, go back to your PC. You have additional disk attached to it, which you are just removing and keeping it for later use. You might want to use that disk on a different machine. So the same thing we are doing here. But it's not physical. It's going to be virtual. Come on, does it take so long? Okay. So let's see if you can create and detach the virtual disk. Under data disk. So under data disk, yeah. So this is the data disk. You can see here. This is the OS disk, which is by default created, the operating system disk, along with the virtual machine. And the capacity of that virtual disk is 127 GB by default, based on the size of the virtual machine. And now here, what we are going to do in the data disk, we are going to create and attach a new disk, right? So create and attach a new disk. Okay, let's do that. And I'm going to give it a name, VM1 disk 1. That's the name of the virtual disk. And the storage type is going to be HDD. Remember, this again comes down to the cost. The regular disk drive costs you less compared to premium SSD, solid state drive. You must be knowing the difference between a normal hard disk drive and the SSD, because nowadays it's very common and everyone knows that SSD gives you much better performance on read write speed of the data. So we are going to create one as standard HDD here, okay, and it's going to be 32 GB in size. By default, it is 32 GB, and you can see it gives you maximum IOPS 500 per second, input output per second throughput. Okay, so let's click apply. So it will create a virtual disk now. Okay, successfully created the disk, updating virtual machine. And after the disk is created, we are going to detach it, right? So you refresh this, and you can see that there's a disk created here. This is a disk. Where is the option to detach? Click detach. If necessary, scroll down to the right to view the detach icon. Scroll down. We are in the down. Is this a detached one? Yes. So you see, there's a very tiny icon at the end of this disk. I hope you are able to see and follow on the screen. I'm clicking detach. That means you're literally removing a hard drive from your physical PC and keeping it aside. So where is this hard disk created? The additional disk what I've done, it is created in the storage in the background. Okay, so I detach the disk. So now my virtual machine VM1 does not have an additional disk assigned to it. We created it, we attached it, then detached from the virtual machine. So while we are doing it, we'll see in the next steps. There must be a purpose for this lab, right? So in the step 7, search for and select disk. Search for and select disk. Okay, it is not detached. It is still happening. So search for and select disks from the list of disks. Select VM disk 1 object. Okay. The overview blade also provides performance and usage information of the disk for the disk. Okay. Right. So let's wait for this process to complete. Oh, there are two processes running now. Resizing of virtual machine and detaching of the hard disk. Let's quickly go through this steps. We'll see what we are going to do here. So after detaching the disk, we are going to look into the details of this disk and the settings, size and performance, storage type. We are going to change the storage type to set the storage type to standard SSD. So while we created the virtual hard disk, we created it as standard HDD. That is slower than the SSD. So here we are going to change the disk type to standard SSD, and then we are going to save it. Then navigate back to VM1 and select disk. And the data disk section, select attach disk. So it's just simply showing you the options of creating a virtual disk, detaching it from the virtual machine, and attaching it back to the virtual machine. So when you detach this virtual hard disk, 30 GB of size, and the type HDD by default. What we didn't did here is available in the storage. So even you can go ahead and attach this disk to virtual machine 2, which we have in our virtual machines list. So you can attach this disk to that VM as well, right? So we are just following the process here to create the disk, detach it, and change the size of the disk from standard to uh, standard HDD to standard SSD, and then attaching it back to the virtual machine. So that's the process we are going to follow here. And then after attaching virtual VM disk 1, verify the disk now. It should be SSD. Apply the changes. So you have now, with this exercise, you have now created a virtual machine, scale the SKU and the data disk size, right? So this exercise explains you creating virtual machines, two virtual machines at the same time, and deploying those virtual machines in two different zones, which means two different data centers. And then we have seen uh, upgrading the virtual machine, basically, which is the vertical scaling. We're scaling up the virtual machine from one particular size to the higher size. And we have seen creating a virtual disk, attaching that virtual disk as a data disk for your VM machine, detaching it, changing the disk type, and attaching it back. So all this, it is the purpose of this lab is to show you how you can make changes on the virtual machines on any level you want, not just the disk level. Any component which can be attached and detached, you can easily do that on the virtual machines. Now the next exercise is Azure Virtual Machine scale set. We are going to the scale set now. Task 3, what are we doing here? We are creating a scale set, and we are going to deploy our virtual machine. We are creating the scale set is going to create the three virtual machines, and those virtual machines will be deployed across 3 zones, zone 1, 2, and 3. And in task 4, we are going to set the custom auto scale rules. So this is where you will see what are the rules you can set for scaling up your, this is the horizontal scaling. So adding virtual machines, more servers in your group instead of upgrading the existing server. Because when you're upgrading, there's a limit. You can upgrade a virtual machine to the maximum size. But if you need more processing power, you have to scale out. You can't do the scale up, you have to do the scale out. And again, that depends on the application which you're running on the virtual machine, whether it requires just the scale up or the scale out. Okay, so our virtual machines updated, and our disk is also detached, I guess. It's not showing here detached. Okay, now it is detached. Apply. Okay, now you can see that your virtual machine VM1, virtual machine 1, where is it? Go to the disk to see how many disks it is having. It has only the operating system disk. There's no additional disk assigned. Now we want to assign a disk. We look for the disk which we created. Attach existing disk. Oh, what is this? Discard changes. So what are the steps? We'll go to the steps here. So after creating the disk, we detached. Now search for the for and select disk. So we are going to search and select this disk which we created. There is option to search. Okay, I don't see an option here to search for the disk. Filter by name. It's not showing anything. Attach existing disk. Okay, here we have to search. Yeah, it is actually showing you here. Disk 1, which we had created already. It's available here. So I'm going to the disk type. M1 disk 1. Disk in resource group. Okay. So this was the standard HDD which we created before. Now we want to change the size, right? The type from HDD to SSD. Don't see an option here changing this. Also provides performance and usage information. Okay. From the list of disk. Let's see if we can search the disk directly here. Disk. Go to the disks. Search for our disk, what we created. We have too many disks here. Okay, so you can see that your disk is visible here. Now let's see if we can change the type of the disk. Okay, settings, configuration. Now I'm editing the disk setting. You see, I'm actually changing the setting for the disk. So I want to upgrade this disk from hard disk HDD to SSD. So we are going to upgrade it to premium or standard SSD. Standard SSD and save. So now this is out of the VM. We have detached the VM, the disk which we assigned to our VM earlier. Now we are upgrading our drive, the disk drive, virtual disk drive, from the regular HDD to SSD. Now I want to go back and assign this upgraded disk to my virtual machine. So I'm going to the virtual machine back. So I'm now, if you see, I'm in the VM settings. That's my VM name. Okay. Under the VM, I'm going to the settings again, and I'm going to the disk. And here I should be able to attach the disk now. Attach an existing disk. So we have this disk which is already available. And now it is a premium SSD, not HDD anymore. I'm going to apply the setting. So that's about scaling up the virtual machine manually. Now let's carry on with our next exercise. Any questions here so far? Am I going too fast? I hope you are able to understand what I'm explaining. And the lab is very helpful.
Yes, sir. Understand.
So let's carry on with the task. Now we are going to see how we can do the scale sets, auto scaling. Okay, this is our task 3. We are creating the virtual machine scale set and also configure the scaling rules. Create and configure Azure virtual machine scale set. In this task, you will deploy virtual machine scale set across availability zones. VM scale sets reduce the administrative overhead of automation by enabling you to configure metrics or conditions that allow the scale set to horizontally scale. Right? This is what is important to understand here. This virtual machine scale set basically reduces the admin effort for you to manually scale up add the virtual machines when as and when required. And it also can do scaling. So virtual machine scale set is not just for scaling out, it is also used for scaling in. So based on the rules which you define, Azure is going to automatically add a virtual machine based on the rules, and those rules will be based on the performance of the virtual machine, the CPU utilization and the RAM utilization. It will automatically add a VM, and when the load is less, if your CPU utilization is below 50%, we can say scale in. That means remove the virtual machine and reduce the cost and save the cost for me. So this is all the auto scaling part. Now we'll see that how we can do that. In the Azure portal, we are going ahead with the virtual machine scale set. Let's see here. All right. So right now we don't have any scale set configured. We are going ahead and creating a new scale set. Okay, so here we are going to do the basics tab, create a scale set. In the scale set settings, we are going to give this configuration. Again, there are some mandatory fields, subscription. So the star fields are all mandatory. You can't skip those. And you have to associate a source group. And the name you have to give for your scale set. So here it is giving the scale set name is VMSS1. And in the real time, I would not give this name. I would be giving it a meaningful name. For example, if I'm creating this scale set for my web servers, so I'll name it after the web server, the application name, VMSS web server. So I know that this scale set configuration is applicable for the web servers. So it will add up the web servers based on the load on my web servers, depending on the demand. East US, we are going to keep it in the East US, same region. And here we are choosing 3 zones here. So it is automatically created, selected 3 zones. So auto scaling can help you respond to an outage. You can see the note here. Can help you respond to an outage by scaling out new instances in another zone. So there are 2 purposes of scale sets. One is in terms of data center outage. If there are 3 data centers, we are deploying this skill set. So if zone 1 is down, the whole data center is down due to whatever reason, natural disaster or whatever, your virtual machines will still be running on 2 different zones, and the scaling will also be done automatically. A scale set, okay, let's go with this. Orchestration mode is uniform. There's no expression right now what it is. We'll see. Optimized for large scale large scale stateless workloads. Stateless workloads, I'll explain you later what it means. But for now, just we'll just carry on with this one. Security type standard. Scaling security type is going to be standard. And scaling option, review and take the defaults. Okay, scaling options, we're going to review and take the defaults. There's the scaling option. Okay, scaling mode. So scaling options, review and take the default. Okay, so what we are doing here, scaling mode is manually update the capacity, maintain a fixed amount of instances. So you have 2 options here. Manually scale up, or you can do the auto scaling based on a CPU metric on any schedule. So these are 2 options here. So we are going with the default settings now. Instance count, that means how many virtual machines you want in this skill set. And default, we are keeping it default 2 right now. And which OS you want, we are going to go ahead with this documentation is quite old now. We don't have 2019 OS supported anymore, so we have the latest version 2025. And run with Azure Spot instance. You can see that it's all going to be same options as you create the virtual machine. We are not going to use any Spot instance. We don't know yet what is the Spot instance, and we'll be discussing that later. I'm selecting the the OS image that I've done already. And Spot instance is unchecked. Size is going to be D2SV3. That's already there. And I'm now going to create the admin account. So I prefer to use Azure admin as a username, and you can give the password. Okay. Right. So let's carry on. Now it is going to the next steps, which is creating the virtual machines. So note here again, for the list of Azure regions which support deployment of Windows virtual machines to availability zones. Refer to what are availability zones in Azure. Okay, it's just giving the note that you should know what the availability zone means. Let's carry on with this. And now during spot. Okay, it finished the creating of this VM skill set. Just ends here. This is all nothing but the virtual machine settings, right? But we are creating the virtual machine in a skill set. So we are doing this after this. On the spot tab, accept the defaults and click next. Next is the spot tab. We are accepting the defaults. Going to the next one, disk. In the disk tab, we are going to accept the defaults again. Okay. Going to the networking tab. In the networking tab, we are going to select. There's some specific settings here. Edit virtual network link. Make a few changes here. Okay. So name of the virtual network. we have our virtual network already created. Address range, or it is creating a new virtual network here. Okay. Name of the virtual network. Edit virtual network. I will name this. We'll give this IP range. Okay. /20 subnet 0. Let's create subnet 0 here. It names it as subnet 0. Default subnet, name of the subnet is subnet 0. And this is the subnet we are creating under it. /24. Let's make it /24. Okay, it is /24 already. So under /20. Okay, /24. Right. This. So we are creating a new virtual network and the new virtual subnet under it. Okay. Save this. Right. So here, what is happening is NIC network NIC network security group section, advanced tab. Okay. Create new configure network security group. Okay. Network interface. It's not creating interface here. Edit the network interface. Okay, so we are editing the network interface. Going back to this, close this one. So the existing network interface, what we have, we are going to edit this. Right. Go to the advanced edit network interface for NIC network security groups section. Select advanced. NIC network security group, select advanced. In the advanced, we are going to create a new, click create new, configure network security group. So we are going to create another configure network security, create network security group. So we are basically creating a network security group here for communication control. Okay, it's already there. VMSS1 NSG, and we are adding some rules for communication rules. I'll explain you on whiteboard what we have done, what we are doing here. Don't worry on if you're not able to follow this thing. So we are going to create an inbound rule. Inbound rule is already there's one inbound rule already there. We are going to add an inbound rule, and source is any. Yes, any. Source port range is star. Destination is any again. Destination is any, and port is going to be HTTP. So we are going to select HTTP here. HTTP, and we are going to set the option allow. This is allow, and the rule priority is 1010 by default. It is there, and the name of the rule is allow HTTP. Allow HTTP. Oh, where are we? Sorry. Okay. No. Yeah, so add the rule and click OK. So we are adding the rule. So what we have done is we have created a rule allowing the HTTP access and click OK. Right. In the edit network interface blade in the public IP address section, click enable. There's the public IP. Yes, public IP address section and click enable. Click OK now. Right. In the networking tab under load balancing section, we are going to use Azure load balancer. Azure load balancer selected here. Create a new load balancer. Select create a new load balancer. We have not discussed Azure load balancer. It's part of the network Azure virtual networking. I kept it for the latest sessions because in order to understand the load balancer, you should understand few other components in Azure. So we have just follow the exercise. I'll tell you in the whiteboard what exactly we have done. So I'm going to create a new load balancer. And the name of the load balancer we are going to give as VMSSLB. Okay. Pause for a minute and review what you have done. What you've done. At this point, you have configured the virtual machine scale set with disk and networking. In the networking configuration, you have created a network security group and allowed HTTP access. You have also created a load balancer with a public IP address. So it's again, it is giving you the note that yes, you have to pause here and understand what you have done. So let me explain you what we are doing here on the whiteboard. Okay, whiteboard is loading. Right. So we're discussing about the skill sets. So what are we doing here in the skill set? We are doing multiple activities here. We have created during the skill set itself, we are creating virtual machines. There are two virtual machines we are creating, and we are selecting the zones 1, 2, and 3. These are the zones. We are creating right. 1 second. Virtual machine skill set with the disk and networking. In the network configuration, we are creating a network security group, NSG. You know what is NSG? NSG is network security group, wherein you can create the communication communication to the VMs. So we are creating a rule allow HTTP access, which is a port 80 to these VMs, what we are creating. Okay, but on the group level, on the scale set level, what we have created, and we are now creating a load balancer.
Masud bhai, are you writing? Are you writing something?
Yes, you're not able to see it.
No.
1 second. Okay, it's actually
We
the
can see
whiteboard.
actually.
You can see it. Someone can see it.
No, sir, I can't see.
Okay.
I'm thinking my net
Let
is
me-
slow, so I'm slow.
Let me stop sharing this whiteboard and share it again. This is within the Teams. So are you seeing the whiteboard loading? Can you see something now? Scale set
Yes,
1,
yes,
2,
we can
3.
see now.
Yes.
1, 2, 3. Right. So scale set. I'm just explaining you what we have done so far in the lab. Step 1, we have created 2 VMs as part of the scale set creation. Step 2, we have created an NSD network security group where we are allowing the communication on port 80. Step 3, now we are creating the load balancer. So now what does the load balancer sir do? We have not discussed load balancer, but I will just give you the high level overview here. So load balancer is another component of Azure virtual network, which does the load balancing. By the name itself, it tells you what it does. So let's say I have two virtual machines deployed. Okay, I'm drawing. Hope you are able to see it now on the left side of the screen. So I'm deploying two virtual machines, virtual VM1 and VM2. This is going to be my web server 1, web server 2. That means, how does it become a web server? Only when you decide to make it a web server. You install the web server application on this server. If it is a Windows server, do you know which what do you say, which application you use for making a Windows server as a web server? Anyone? If you want to configure your Windows server as a web server, you will use use the application called IIS, Internet Information Service. So this is the application which you will be installing if it is a Windows server. If it is a Linux server, you have various uh, applications available. One of them is Nginx. This is the web server application. So you'll basically install one of this application on the web server, and you will have the data stored on the web server. So you will have the data. Now, when you're deploying these web servers for load balancing, you have to make sure that the data is consistent across both the servers. Otherwise, what will happen when the users are browsing the internet, browsing your website? Let's say I'm doing this for my website, abc.com, right? Okay, the screen is not being visible properly. I think it's not refreshing quickly,
Yes.
right? You can't see the other side of the screen. I'm just trying to
No, we cannot see
minimize.
the abc.com.
Yes, exactly. So that's an issue with the Teams application here. I'm using the whiteboard within the Teams, so that's the problem. Okay, this is the last time we'll be using this one. Okay, so now you should see that. Okay, so how do I make the web server? How do I make my virtual machine as a web server? You have to install the application. If it is a Windows server, I have explained you that you need the IIS application running on it. If it is a Linux server, you need Nginx running on it. So this is my these are two web servers, and I have my data on web server. This data has to be consistent, same on both the web servers if you are trying to use them as the load balancer. So this is my website, abc.com, and the content of this website is loaded on my are stored on my web server. So how now for you it is two virtual machines. Now for the end users, they don't really see what is happening in the background, right? So if I'm a user, okay, internet user, I'm trying to browse the website, www.abc.com. Okay, so I might reach to one of the web server. It's not that the request will go to both the server at the same time. So if your data is not consistent, and first of all, this is not load balancing. You have just built two virtual machines. There's no configuration or component which says that okay, this user's request should be distributed equally. It should be load balanced between these two servers. The purpose of having two virtual machines, two VMs for the web server is to make sure that my website is highly available. If one server goes down, the website should be still accessible over the internet, and it should still serve the users what they're looking for. So there is a concept of load balancer. It's a third component which you have to include here. So in Azure, you can configure the load balancer. Okay, we have not seen this yet. We'll see this in later classes. So you can configure the load balancer and assign this load balancer the public IP address of your website. Okay, for the abc.com, whatever public IP address you have used for mapping it. So that public IP will be assigned to the load balancer. So when the user browses abc.com, the request will come from the user to the load balancer. Okay, it will terminate here, and this load balancer will equally distribute the load to your servers in the backend, the web servers what you have, web 1 and web 2. So you have to make sure that the data is consistent, because now you're configuring the load balancer. You're saying that when the users are trying to access my website, the load should be balanced. So if there are 100 users who are accessing it, so there should be 50 users connecting to one server, 50 users connecting to another server. So that's actually the load balancing. And this component does all of that job. It is built to do that job, the load balancer, right? I hope you are able to understand what I'm saying here. I'm just refreshing the whiteboard because it's not properly visible. Okay, are you able to see now what I'm trying to explain? I'm explaining you this block. I'm explaining you the concept of load balancer, right? So when you implement the load balancer, we'll see that in the next classes. You build two virtual machines, but you have not built any load balancing functionality between those two virtual machines. You've just built two virtual machines. That's it. So for the end user, it will not be visible. They don't know how to reach to a specific web server, how the load balance should be done on your network level. So this is a load balancer, which is a network component. We'll be seeing, we'll configure it and see in practical how it works. So for now, for this exercise, just understand that uh, with the skill set, when we are configuring the skill set, we're doing all this configuration together. We are creating two virtual machines, deploying in different zones. We're creating a rule, NSG rule, to allow the communication on port 80, to be able to enabling the communication for anyone to access my website. Number three, we are creating a load balancer. So that the load of my website is equally distributed. And this also does one more function. It's not just a load balancer. It will also make your website highly available in case of disaster. If let's say your server is down, web server 1 is down. There's some issue. Your web server 1 crashed. So in that case, the users will still be able to access your site, and the load balancer will automatically send your website request to the web server 2, and it will stop sending traffic to the web server 1. Right. So with that explanation, now I'm going back to the exercise. So this is all we are doing in this lab. Okay, so we are creating a load balancer now. The load balancer, where is the load balancer? Yeah, create load balancer, and we are here giving the name of the load balancer, VMSS LB. On the create load balancer page, specify the load balancer name. We have done that already. On the management tab, specify the following settings. So this is just, it doesn't explain you. Now there are different options available in load balancer again. Public load balancer and the internal load balancer. We'll see all of this later. Don't worry about that. I'm just going at and creating the load balancer. And then we are going to the next management plate. So in the management tab, disable the boot diagnostic. It says, okay, let's make sure that it is disabled. Where is the boot diagnostics? It's here. It is disabled now. And go to the next health tab. Next is the health tab. And in the health tab, review the default settings without making any changes. So we are reviewing the default settings. In the health tab, what do we see here? These are all related to the VM skill set. Health monitoring, it does monitor the health of the machines. That's how it basically does the upscaling or the scale out of the VMs. Now we are going to just click on the go to the next tab, advanced, and review and create it. Review and create. So we'll see if the validation passes. We'll go ahead and create the skill set. And the validation passed, and we are going to create the skill set. This might take some time, because it is doing a lot of configuration in the background. It is creating two virtual machines, It is creating, as per my whiteboard explanation, it is configuring the load balancer as well. So that's going to take little time. So wait for the virtual machine scale set deployment to complete. This should take approximately 5 minutes. Okay, that's fine. We'll carry on with the next step. Now, task 4, scale Azure virtual machine scale sets. In this task, you scale the virtual machine scale set using a custom rule. Now we have not configured the scaling rules. With these rules, you will enable the scaling. 1 second, give me a second, please. Right. So in this task, you scale the virtual machine, go to the resources. Once okay, it is created actually. The scale set is ready. That was not 5 minutes, it was very quick. So you can see the scale set is created and it represents you with multiple virtual machines because that's the concept of scale set. So now we are going to set the rules for the scale set. Choose the availability plus scale option. We are going to the availability plus scale option and we are going to choose scaling. Scaling. Okay, you can manually scale or custom auto scale. Okay, in scale sets with the small number of VM instances, increasing or decreasing the instance count, manual scale may be best. That is saying if you are having a limited number of virtual machines, in this scale set, you can manually scale up and scale down the scale set. In scale sets with a large number of VM instances, scaling based on metrics, custom auto scale may be more appropriate. Okay, so scale out rules. Let's look at the scale out rules now. Select the custom scale out auto scale. With custom auto scale, yes. So this is the custom auto scale option. Metric source, current resource. Okay, metric source. This is our scale set. Namespace virtual machine host. Where is this? Let's see these options. Because these settings, the interface keeps changing. I told you, Microsoft keeps enhancing this interface. You might not find all the options in the lab exactly in the same place. As you have seen, the VM sizing is not updated in the documentation. We don't have the Windows 2019 anymore. We have selected 2025 version instead. Okay, custom auto scale rules. Auto scale setting name. So auto scale setting name is VMSS1. Auto scale setting 3. Okay. It has okay. So I think I'm missing something here. Okay. Select scale customs auto scale, then change the scale mode. Okay. Change the scale mode to scale based on metric. Where is the scale mode? Let's look at that. Yes, here the scale mode is here. So it says scale mode based on metric. Do you see based on metric? I don't see anything here. Mhm. So this is all changed now. See, okay, here down in the default settings, you can see scale mode, scale based on metric. This is what it is telling you. So we are changing this settings based on metric and then add a rule. So now we are going to add a rule, add a scale condition. That's the rule it says. Let's create a rule that automatically increases the number of VM instances This rule scales out when the average CPU load is greater than 70% over 10 minutes of period. So now this is the condition, this is the rule you're setting for scaling up. Your VM, sometimes the CPU might spike, the load might be higher, but it might settle down within the 10 minutes. So you don't want to scale up, add up a new virtual machine just for that 10 minutes time of the CPU spike. So you're setting a rule here saying that, okay, if my virtual machine reaches 70% of utilization and it stays constantly above 70 for 10 minutes, then trigger this rule. This is the rule, auto scaling rule you are setting here, right? That's the first condition you're setting. So go ahead and create a new virtual machine for scaling, auto scaling. When the rule triggers, the number of VM instances increase by 50%. That means if your VMs, if you're having a scale VM, two VMs in the virtual machine skill set, it is going to increase that quantity with the 50% more. That means it is going to add one more VM. It's going to create have a three VM in this scale set automatically. So 50% that's the rule we are going to set here now. So let's create this rule, add a scale condition, scale based on the metrics. Are we doing the right thing here? Let's see. This was the default scale based on metric, and add a rule. Okay, the rule option is here. You can see. So within this window, you can see there's a add rule option. I'm clicking that. So in the rule option, I'm going to create a rule, custom resource. Okay, current resource. Okay, a virtual machine host. Metric is virtual machine uh, host, right? Percentage CPU. Review your other choices. Okay, percentage CPU. There are other options available here. You can see you can, based on the disk performance also, you can do the auto scaling. But here we are particularly using the CPU utilization. Operator greater than, and the operator CPU operator is greater than. So we are going to set greater than value here, right? Greater than 70. Metric is going to be 70. VM name, it says VM name. VM name, operator, time machine values. Let's see if we are missing anything again here. So we are creating a metric source. Okay, metric namespace, virtual machine host, metric name, percentage. Metric name is in percentage CPU. Okay, operator is going to be greater than, going to be greater or lesser. There are two options only, equal or greater or lesser. That's the operator. Metric threshold to trigger scale action 70. Scale action percentage 70. So we can define here 70, I guess. Okay, yeah, here we have an option. Operator greater than, not here. We are not changing anything here. We are going to this option. Greater than 70. Okay, that's default setting. Duration 10 minutes. And we are going to see for 10 minutes before auto scaling. If the CPU constantly remains at the 70% utilization, and then time grain statistics average, uh, time aggregation average. Let's I'm not explaining these options, all the options here. We'll just go by this exercise. Operation increase percent by, okay, increase percent by, we are going to set the rule 50%, right? If there are two VMs in our scale set, it's going to add one more VM. Let's say gives you here all the options, %50, and that's our rule. Got it? So we are setting the auto scaling rule, and in the rule we are saying it will be based on the metrics. And what are we doing here? We are defining the rule to scale out. When to scale out? When average CPU utilization is 70%, and for 10 minutes. So increase percent by 1. So the by 1 is what? It's nothing but it's going to increase the capacity by 50%. Cool down 50 minutes. No, cool down. What is the cool down time?
Cooldown is 5, I think so.
5 actually. Yeah, exactly. Cool down is 5 minutes. That's a 5-minute actually average time. It's not 50. So percentage is 50 actually. So that's the rule, correct rule, which we have set now. And we are going to save the settings, update, and save this rule. Right? That's the scale out setting. Now, do you want to set the rule for scale in? Yes, we want to do that as well. During evenings or weekends, demand may decrease, so it is important to create a scale in rule as well. We are not just creating a scale out rule, we are also creating a scale in rule. Let's create a rule that decreases the number of VM instances in the scale set. The number of instances should decrease when the average CPU load drops below 30% over a 10 minutes period of time. When the rule triggers, the number of VM instances is decreased by 20%. Select add rule now. We are going to add rule again. Add a rule. Operator is less than. So we are just straight away going to the operator. Is less than 30%. And operation decrease percentage by decrease percentage by 50. Okay, this is the rule we are setting for scaling in, and create the rule. So we have two rules now. For scale out, average CPU utilization 70% for 10 minutes. Go ahead and add the capacity, 50% more capacity. That means if you have two VMs, it will create one more VM. And scale in, it's going to decrease the capacity. If the average CPU is below 30%, it's going to decrease by 50% the capacity. So set this instance limits. Right, let's see this. When your auto scale rules are applied, instance limits make sure that you do not scale out beyond the maximum number of instances or scale in beyond the minimum number of instances. Okay, instance limits are shown in the scaling page. Instance limits are shown in the scaling page. So we are setting maximum and minimum capacity of our virtual machines. So minimum capacity is 2, maximum 2, and default maximum is 10. We can the auto scaling can go up to 10 virtual machines. So that's the maximum limit we are setting. Default is 2. And when we are scaling back, there should be minimum 2 virtual machines left. Otherwise, there's no point having the virtual machine scale set configured. So we're going ahead and saving this scaling settings. Right, once we save that setting, this is a pretty long lab actually. It's taking the whole day for us, whole session. Okay, but it's really I hope it will be beneficial for you to understand. Although you might not get a chance to implement it yourself, but when you're approaching for a new role, if you're applying for a cloud admin role, you are aware, that there are options available for scale out and scale in. There are different ways and features available in cloud. So this is not specific to Microsoft Cloud. Similar, as I told you, all these features are available across all the platforms. The naming convention might be different. So here we are calling it as virtual machine scale set. In AWS or Oracle or Google Cloud, it might be having a different name altogether. So what is important for you to understand is the concept of scaling out and scaling in. And similarly, all the concepts what we are discussing in this series in the bootcamp. right? Now the task 5 is create a virtual machine using the PowerShell. So that's it. In this exercise, this is the main this was the main objective here, creating the scale set. So I've explained you on the whiteboard. While creating the scale set, it is also creating the load balancer. There's a time here for call to prayer. I'm just pausing for 2 minutes. We'll just quickly complete this lab. If you want to see these 2 tasks, we can finish it very quickly, and then we'll take a break for half an hour. So I'm going to the task 5. Although we have already done this, we have seen this before. Let's quickly see what the task 5 is doing. It's creating a virtual machine using the PowerShell. Now this is the we are going to use the Cloud Shell. Use the icon in the in this. You know that on the Azure portal itself, you can run the shell in 2 different modes. You can run it as a PowerShell in PowerShell mode or in Bash mode. These are the 2 modes you get. So we are going to launch the Cloud Shell, and then we are going to use PowerShell particularly. Switch to PowerShell. Yeah, that's fine. Running the following command to create a virtual machine. When prompted, provide a username and password for the VM. While you wait, check out the new AZVM command results. Okay. So what are we doing here in the command? We are creating a new virtual machine, AZVM. We are going to use our resource group, specify the resource group. Name of the virtual machine is my PSVM, a PowerShell VM, just for your lab purpose. Location ECS. Image, and we don't have this image available, so we might have to update this in the script. And zone 1, we're going to deploy a standalone virtual machine, and this is the size and this is the credentials. So get credentials means it will prompt you to set the username password. Let's see that quickly. Okay, it is asking for the username password, so I'm going to create Azure admin as a user and my password for the VM access, right? So it is going ahead and creating the resource. So I guess the VM, the OS version, Windows 2019 is not visible in the dropdown, but it is still available in as the image on portal. So that's why it is going ahead and creating the virtual machine. If it is not available, it might fail. So let's see what happens to this. So it's going to create a virtual machine. Once the command completes, you can use the command get azvm to list the virtual machines in your resource group. So we are going to use this command to see in a specific resource group how many VMs we are running. So let's copy this and wait for this process to complete. Let's see what else we have here. Verify your new virtual machine is listed and the status is running. And then you can also use the command stop azvm to stop the virtual machine. And then use get azvm with status parameter to verify the machine is deallocated. So when you stop the virtual machine, it will show you the status as deallocated. That means when you use Azure to stop your virtual machine, the status is deallocated. This means that any non-static public IPs are released and you stop paying for the VM. So, if you are using the public IP for your VM to access, it gives you the note that the public IP will be released for the virtual machine because you're not using the static public IP here. The moment you create the virtual machine, it is automatically creating and assigning a dynamic public IP for you to access your virtual machine over the internet. So it will release that IP, it will stop the virtual machine, it will stop billing you for that virtual machine. So when you restart the virtual machine again, your public IP might change. So it will assign again from the pool of Azure. So we'll see this now. Okay, the virtual machine is created. So let's go and check the virtual machine status. And you can see your virtual machine. This is the resource group name. This is the virtual machine name. ECUS. This is the OS, the size of the VM, OS type Windows, and this is the network interface card, and it says succeeded. provisioning is succeeded and it is running. That means your virtual machine is up and running. Now we will go ahead and stop that virtual machine. Okay, it is asking you whether you want to do it. Go ahead with this because it will shut down the virtual machine. Yes. It will go ahead and shut down the virtual machine. We'll see the status again with the help of this command. Let's carry on. You can see that later. Create the virtual machine using the CLI. Use the icon again, Cloud Shell. Now we are using select bash. We have already seen this. I don't think we have to go through this again. You can do it on your own. Right. So this is where we stop now for a break. We'll take a half an hour break, and I'll be back. So this is now done. The virtual machine is created. It's stopped actually, and you can see the status of the virtual machine is deallocated. Right. We're stopping here for the break now. See you in the next 30 minutes, and wrap up today's session. So what do we have next is let me see. So we're done with that lab. It was pretty big one, but I just want to make sure that you understand the concepts what we are learning from these labs. If you have any doubts, you can always take the notes. Have your doubts noted with you. If you don't want to ask in the session, you can do that later. You can approach me as well. Based on my availability, I'm very much occupied over the weekdays, but still you can text me and I'll reply to you or respond to you whenever I'm free. So the next our next topic is I guess storage. Let me see. We have done. We reached here in the scaling. Right. So we did see all of this, and we have already discussed what are the the deciding factors for the virtual machine deployment. Name of the virtual machine, location, size, pricing, availability, disk, image, operating system, and we have also understood the responsibilities of the virtual machines. So here there's a quick, the process, the flow diagram here on your decision factor of the virtual machine. You start here, decide to build the new, here you can decide whether you want to build a new virtual machine. If it is yes, if it is a fresh deployment, you are setting up a new virtual machine. Do you require full control? If you need that, you have to go ahead and deploy the virtual machine. If you're migrating from your on-prem to the cloud, so we have also discussed the concept of lift and shift. Basically, that means you're moving your virtual machines which are already running in your on-prem environment to the cloud. So you can migrate the virtual machines from your on-prem to the cloud. Can be containerized. It basically depends on what application you are moving to the cloud. So we have the new options in the compute and Azure. You can run your application in a virtual machine. You can also use the containers. You can if your application supports containerization, you can do that. Or you have an option to deploy the application as a web app, or the API app. We have not seen these options. We'll be seeing this in the later classes. So basically, it is not necessary that you always deploy a virtual machine to run an application in the cloud. In the cloud, you have flexibility, you have options. You can, if your application supports if it is supported on containers, you can run the application in the containers, or you can even configure and make use of Azure web app, or the API app. So these are the deciding factors when you're deploying the application or the compute when you're choosing the compute on Azure. So either you need a full virtual machine, complete virtual machine, and you run the application on it, or you migrate the your application to the container or to the web app. So that's it on the virtual machines. Now the next topic what we have is let me see where we are. Yeah, we have the storage next. Let's start our recording. I guess I stopped it. No, it is still running. The recording is on.
Yeah.
Okay, let's try to understand the what happened. My screen went blank. Okay. So next topic is storage accounts. Now, there's a quick whiteboard discussion on the storage account, non-relational storage accounts and blobs. So we'll see there are different types of storage accounts, and these are the uh, features related to the storage account. So you can have the authentication and authorization configured on the storage account. You have storage tiers. We'll see what are the tiers: premium, hot, cool, and archive. What are the administration options for managing your storage? We'll see that as well. Then we have data protection. What level of protection you can do on the storage account in Azure, and account types as well. So yes, we should have started from here, going all the way back to the data protection. So these are the different type of storage accounts you can create. We'll see the difference. What exactly the storage? Storage is where your data is kept, right? In a very simple and layman language. It's a storage where your data is kept, protected, and retrieved whenever you need it, right? So nowadays it's bit easier to explain what the storage means because everyone is in this smartphone era, and we know when we are buying a smartphone or the device of the phone, we look at various features of it. The storage capacity is one of that. Uh, we we try to inquire how much data we can store on your photos, videos, audios, whatever it is. So similarly, when it comes to your organization needs of storage, you can make use of storage on Azure if you're straight away going with the storage option in Azure, or you can also deploy the storage in on-prem scenario. There are different technologies available when you're deploying it on-prem. There is NAS, network attached storage. There is SAN, storage area network, various options in deploying the storage on-prem. Here we are particularly talking about the storage accounts on Azure. So let's carry on with this. Continue. So you understood, right? What is the storage? We know it's a place where you store the files. Storage service, a service that you can use to store files, messages, tables, and other type of information. Now there are four type of storage accounts you can create. In the storage, you can create four types, different types. Azure containers stores large amount of text or binary data, which is object storage. You can see this is your storage account here. And this storage account, you can create a container storage. You can create a table storage. You can create a queue storage and the file storage. The most common one, which are used in the infrastructure, are the containers, because this is where you can store the general storage, the general file types like images, documents, video, audio, any kind of files, and even the VHDs, the virtual hard drives, which you create for your VMs. If you need a custom disk to be assigned, you can create the virtual hard disk, and you can store that in your storage account. So this is general purpose storage, the blob storage, the container type, and the blob storage is the general purpose. The table and the queue, these two types are particularly used by the applications. If you are an application developer, you would know how to use this in the application deployment. So we're not touching base these two type of storages here. We are mainly concerned about containers, blob containers, and the file storage. So file storage is nothing but like a regular file storage which you can have on your on-prem scenario. So it functions as a file server. So we'll see how we can make use of these two storage types. So Azure Tables stores simple structured data in a NoSQL format. So those who are aware of application development, they will know what NoSQL format is. Azure Queue stores messages for communication between application components. So when you're building an application, when you're developing an application, you can make use of Azure queues in your application component. I don't have a use case for right now with me to explain you these two storage types. We will focus on Azure Container and the files. Azure Files, cloud or on-prem file shares managed by Azure. So we'll see this different type of storage accounts which we can create. Now, storage account kinds, all Azure storage accounts automatically use, this is the just a note that all Azure storage accounts automatically use storage service encryption. It's called SSE to protect data at rest. What do you mean by data at rest? There's a concept of data in transit and data at rest. Data in transit means data which is uh, flowing, which is going from one location to other location over the network, and data at rest means the data which is stored in a storage account, like in a form of file or a table or and so on. Storage account, you can create standard general purpose storage, premium blob storage, premium file share, premium page blobs. So the difference is basically the feature, the speed of the storage, and the performance of the storage. This is the most commonly type of storage account you will create, best for most workloads like blobs, files, queues, and tables at low cost. So this is the preferred and most commonly used storage type. So you will get all these options while creating the storage on Azure to choose which one you like for your requirement. For high performance data ingestion, such as big data, analytics, and real-time workloads, this is the type you will go for. So those who are in big data and AI, field, they will know how to utilize this type of storage. Premium file shares for IO intensive application needing fast, consistent file share performance. So you can see the types are mainly relating to the performance of the storage. So when you talk about the storage performance, it's mainly the read-write performance, read-write speed of the data to the disk. So premium page blobs for high performance Azure disk used by VMs, OS and data disk. So this by default Microsoft Azure storage is this. This is where our VM disks are created. So OS disk for the virtual machines and the data disk which are created and managed by Azure automatically. We don't manage the storage where our virtual machine hard disks are stored. Right now there are different options for replication for the storage replication. Now, why do we need the storage replication? You have a simple statement here. Replication equals copying your data to multiple locations for protection and high availability. Right? When you have a data on your phone, you would always feel that your data there should be a copy of your data which stored on some other places as well. Like if you have a PC at your home, you might want to transfer the data and keep a copy of your data what you have on your phone, or you want to keep it on the cloud drive. So you have various options, free storage options available from all the cloud providers, even the free email service providers like Gmail, Hotmail, Gmail, and Gmail provides you the G Drive. Microsoft gives you OneDrive, and there are Dropbox applications as well. So those are the free storage accounts available for you with a limited capacity, wherein you can keep a copy of your data, which is there on your device. So similarly, same concept applies here. Now, who decides whether how many copies you to maintain for your data? Because storage account on Azure, we are creating it for the business. It's not for your personal use. You won't really go and build a storage on Azure infrastructure as a cloud environment for storing your personal files. That will be too expensive for you to maintain. This will be mainly for the business, and the business will tell you that either there's a compliance need that you should maintain multiple copies of data and make sure that your data is available in case of a disaster in cloud services in one particular zone. So again, going back to the business decides, business tells you, or the compliance regulation tells you that you should maintain tells your business that you should maintain this many copies of data, and in the business comes the management comes and tells you as a cloud admin that you should maintain the copy of data, these many copies, and this is all you should, this is a requirement. So for you as a cloud admin, you have to know the options how we can do that using the Azure storage. So these are the options available now. We are just discussing here. While creating the storage account, you see all of these options. Local LRS, locally redundant storage. What does it do? Replicates data 3 times within one data center. Okay, lowest cost, least protection, right? It is a locally redundant storage. That means within the data center, uh, definitely Microsoft in one data center, they will be having different storage units available in the background where you're saving the data. So it by default it maintains 3 times 3 copies of each file which you store on the storage account, but it is going to be in the same data center. If that data center is out due to a natural disaster or man-made disaster or whatever, your data is gone. You have to decide whether you need zone redundant storage of your data. So ZRS is zone redundant storage. What does it do? Replicates data across 3 availability zones in the same region for higher resilience. So again, going back to our region, which we are choosing in all the labs, East US is one of the region of Microsoft. In that region, they have 3 availability zones. That means they have 3 separate data centers in a close proximity, right? So the storage account, while you're creating the storage account, you can choose ZRS as well, wherein it maintains the copy of your data across 3 different zones instead of doing it on within the same data center. Again, the cost will be a little different than the local LRS storage. That was the first one is within the same region, single region, and then you also have an option for going multiple regions, right? So when you're going to choose multiple regions, it is called geo redundant storage. That means replicates data to a secondary region hundreds of miles away for disaster recovery. So if you want your data to be stored in a different region altogether, like we are referring United States regions as an example here. I have my primary storage created in East US, and I want the replication to happen in West US, for example. So East and West, there's a big difference. There's a big distance. So you're storing the data in a different region. Then you have read access GRS. You have, it is similar to GRS. In the GRS, you have read-write copy of data available in 2 different regions. Same as GRS, but also allows read access from the secondary region. Yes, that means in this first GRS type, geo redundant storage, you will have your primary storage in East US and the secondary storage in West US, but that copy will be read-only. That will not be accessible. By default, this copy, which you're seeing, the secondary copy, which is stored in West US, it's not accessible to you. You can only access the primary data source. So if this region is completely out, then you'll have access to the secondary storage, and this is all happening in the background. So you don't have to really do anything manually to access the data from the secondary region. So that happens in case of disasters. So this is the second option wherein you have both the regions available. And in the secondary region, if you want to access the data from the secondary region, it is available only for read access. So that is the option you have in the storage. Then you have GZRS, global, what does it mean? Let's see. Global GRS is geo redundant storage, right? So global zone redundant storage. So store 6 copies of your data across 3 zones plus 1 secondary region. Okay. Protects again against disk, node, rack, zone, and full region failures. So this is the protection. The higher you go in selecting the replication strategy, the higher the cost will be. Writes to all 3 zones, synchronous, and copies to secondary region, which is going to be asynchronous. Read only, again in GZRS, we have read only access as well. So GZRS plus read access to secondary region provides a separate read endpoint. You can check the replication delay RPO to the secondary region. So we'll discuss what is RPO going forward. Right, how do you access the storage? Every object has a unique URL address based on account name and storage type. So when you create the storage account, we have seen in the previous example when we were discussing the fundamentals, we have seen how we can create the storage, and there'll be a URL assigned to every storage account which you can use to access your file storage. So you can access if it is a container storage, you can access with the name. This name will be automatically created based on your subscription, or you can also create your own storage URL based on your domain name. If you have your own domain name, you can create, like for example, mystorage.abc.com, and that will be accessible to your users. If you don't do, you can even create a DNS record. This gives you the example here wherein you are creating a custom name for your storage and the DNS, and you are mapping that to the actual storage URL which Microsoft Azure creates for you while creating the storage account. So there will be a separate URL for each type of storage to access. Container service, which is a blob storage by default, which is most commonly used, and the file service. So table service and the queue service will be used by the applications. Secure storage endpoints. Every object has a unique URL address, you know that, based on account name and the storage type. You can secure your storage access because this storage, the moment you create the storage, it is accessible over the internet. Same like with the virtual machine. When you're creating the virtual machine, your virtual machine has a public IP assigned, and you can access. We have seen that yesterday. You can access the virtual machine anywhere, sitting anywhere in the world, with the help of public IP, as long as you have the internet access. So similarly, when you create the storage account will be accessible over the internet by default. You can enable the firewall features on it, the firewalls and the network virtual network features. Firewalls and VNets control access to the storage account by allowing only specific subnet or public IP. Same concept, like we have seen uh, how we can restrict access to our virtual machine based on a specific IP address, right? I gave you an example. We have seen in the lab that we created an NSG rule wherein I have specifically mentioned that my public IP, which I have assigned on my internet connection, only allow the connection from that public IP. So the storage, you can do the same. You can assign if your organization, if you're connecting to, if this is the storage for your company and your users from your office are connecting to the storage, so probably you can specify source as your company public IP addresses. So that the storage is only accessible for your users sitting in the office, not to anyone who's having internet access. The subnets and the VNets must be in the same region or same region pair as the storage account. So we'll be seeing all these options when we create the storage, how we can restrict access based on the IP and IP address. Now, how do you implement it? Implement the blob storage. What does the blob storage mean? Stores unstructured data in the cloud. can store any type of text or binary data, also referred to as object storage. So this is the storage type. Let's say this is an example. This is my production storage I'm creating. So in the production storage account, I'm creating the container for the blob. There's a container I've created. So I can create the container based on the data type. I've created a container here. It's nothing but like a folders. So within the storage, you're creating different folders or different partitions, you can say, on the disk which you create. So for pictures, storing all the picture files, I'm creating one container. For storing the video and audio files, I can create another container. Common uses serving images or documents directly to a browser. So here, all of this data will be available over the internet through the browser. You can access all this data which you're storing in the storage account through the browser. Storing files for distributed access. This is another reason why you would do that. Since this is the storage account which you are using for your organization, you can enable your organization users to access this storage from anywhere in the world as long as they have internet access. Streaming video and audio, storing data for backup and restore, disaster recovery archiving. You can also use the Azure storage as a backup copy for your on-prem storage. Storing data for analysis by an on-premises or Azure hosted service. So what is binary large object blob storage? A place to store any type of files, objects like images, videos, logs, backups, and documents. Right, now the storage has different tiers available. When you're creating the storage, you can create it as a hot tier for data access very frequently. So that is one of the option you have while creating the storage. You can create it as a cool tier. That means for data access rarely, kept for 30 days. So the data which you access very rarely within, let's say, once in a month for reporting or for some specific activity. So you can create the storage because now this again comes down to the cost. If it is a hot storage and the data is frequently accessed, you'll be charged more for this. If your storage type is cool tier, your data is accessed only once in a month, there'll be lesser charge. If it is cold tier, there are four types here: hot, cool, and cold, and then the archive. So cold tier for data access very rarely kept for 90 days. So once in a 3 month, you want to access the data, that kind of data you can put it in the cold tier. And there's the archive tier for data you almost never access, can wait hours to retrieve. So where will you use this? This you might keep it for audit purpose. So if your organization is audited every year, and there is a requirement for you to keep all the data which your organization is dealing with for 1 year or 180 days, for example, 6 months, every 6 months there's audit happening. So this data is only retrieved when you need it. Okay, it will be slower to access, but only access once in 6 months. So you can decide which data goes where. And storage will tell you the moment you store the files, it will keep giving you the information that these files are accessed very frequently. So you can put them in the hot tier, and then and so on based on the access metrics. Okay, it's not block actually, it's blob cycle management rules. So move blobs to cheaper storage tiers automatically. There are rules you can define. Delete blobs when they reach end of life. You can define the end of life as well for your storage account. Apply lifecycle rules only to specific folders, paths in the storage account. So you can define the lifecycle, data lifecycle. You might not want to keep all the data forever because that will consume the storage and that really costs you a lot. So you can define those rules on your storage account. You can define the rules. So basically, these are basically the rules you can define on your data which is stored in the storage account. Okay. This is another mistake here, spelling mistake. Blob object replication reduces read request latency, improves compute performance. So you can have a replication, the copy of your data in second region. We have seen that there are different options available for that. Storage security. Your storage is having all your important data stored, right? So you can define the security. There are multiple options for securing your storage. We have seen that you can do the firewall control. We have not seen what is the private endpoint and service endpoint. So we'll be seeing that later. You can have authentication on your storage, authentication and authorization with the help of service SaaS, account SaaS. We'll be seeing all of this, what each of this means. And you can also encrypt your data. The data which you are storing on Azure Storage, it can be encrypted with the help of Microsoft managed keys or customer managed keys. It's the same keys concept, public key and private key. You can use Microsoft generated keys or you can use your own keys to encrypt the data for better security. We'll be seeing the difference between these two. Secure transfer, you can also enable the secure transfer of data when you're transferring data from your Azure storage. So all of these we'll be seeing in practical. Give me a break for a minute. I'll be back with you. All right, I'm back with you. So there are different security settings you have, which you can implement on storage account. Storage service encryption encrypts data at rest automatically. This is the automatic configuration. All your data which is stored on Azure storage account is encrypted by default. Enter ID plus RBAC controls who can access storage using identity-based permissions. As you have seen, we can create the different roles on managing Azure infrastructure. Similarly, you can also use the different roles with the help of enter ID identities to create the access level, assign different permissions to different users. Client-side encryption plus HTTPS SMB. SMB is a protocol which is used for file shares, protects data while it is moving over the network. So whether the data is in transit, this is the transit protection basically. When your data is moving from one point to the other point, that means you are accessing data, your storage account on Azure and downloading the file or uploading the file. So that moment is called data in transit. And when the data is stored on the storage, that is called data at rest. These are the two different terms which refers to data protection, basically. So Azure Disk Encryption encrypts a virtual machine disk with keys stored in Key Vault. We have not seen what is the Key Vault. It's like a password manager. When you have the keys, like we have seen yesterday, when you create the virtual machine, Linux virtual machine, you get there are two keys created, public key and the private key. That private key is the actual key which you use for opening or accessing that virtual machine. So that those keys you can store in a safe location. Microsoft provides you a service called Key Vault, wherein you can store those keys safely, right? So your virtual machine disk can also be encrypted. Shared access signature, SAS, gives limited time-bound access to the storage. So you can share a file on your storage with a limited time bound. Shared key authentication, access using the account key, using the private key of the storage, and you will have full access to the storage. And you can also enable anonymous access optional, allows public access to specific containers, blobs. So we'll be seeing all of these options and where we use this. Create shared access signatures. Shared access signature, as you know, I just explained, it provides delegated access to storage resources, allows client access without sharing your main storage account keys. So account SAS gives access to multiple storage services, blob, queue, table, and file. Service SAS gives access to one specific service only, example, blob. So we'll see this in action. When you see this, you'll have a better understanding. Identify URI and SAS parameters, SAS parameters. Shared access storage, a SAS is a special signed link that gives access to storage resource. It contains two parts, the resource URL plus the SAS token, permission plus expiry. So a SAS URL is just the resource URL plus a token that controls how, who, and for how long someone can access it. So when you're providing access to temporary access to anyone, it will generate a URL, and that URL contains all these conditions. So that defines for how long the data is accessible and who can access it. And this is continuation of that, a SAS URL, storage resource URL plus SAS token. This is the normal URL of the blob container file. For example, myaccount.blob.co.windows.net. SAS token, everything after that is basically a token which has contains permissions, expiry, IP range, protocol, and the signature. So that's about the storage introduction, very high level. We have detailed storage discussions as well in the later classes. Let's go ahead and see how we can create the storage. So we'll go back to our labs. In this, we have an exercise to create the storage. Let's see. Okay, so in this exercise, what are we doing? In this lab, you learn to create storage accounts for Azure blobs and Azure files. This is what we are dealing with. I told you we have four types. We can create four types of Azure storage accounts: blob, Azure files, and tables and queues. So we'll be using mostly the blobs and the Azure files. You learn to configure and secure blob containers. You also learn to use storage browser to configure and secure Azure file shares. Let's carry on with this. You'll have a better understanding by seeing what we are discussing. Right. So this is again a 15-minute lab. Understand the scenario. Your organization is currently storing data in on-premises data stores. Okay, that's the background. Most of these files are not accessed frequently. Okay, you would like to minimize the cost of storage by placing infrequently accessed files in lower price storage tiers. Okay, this is the requirement. This is the problem your organization has. Your organization actually wants to reduce the cost of storage, storing the files. The files which are not stored, which are not accessed frequently, they want to move it to a different storage, cheaper storage. We also plan to explore different protection mechanisms that Azure Storage offers, including network access, authentication, authorization, and replication. So these are the options which Azure Storage provides you. Finally, you want to determine to what extent the Azure files is suitable for hosting your own on-premises file shares. So this is another requirement. The first requirement was to move the storage, the less access files to a cheaper storage. The second is you want to also explore to see how the Azure storage can be used as a file share, as a file server. So let me quickly go back to the whiteboard. I'll explain you how this actually looks like in the real-time scenarios. Right, I hope you can see the whiteboard. Right, let's create this one. Yeah, you can. All right. So now we have, let's take an example for this particular lab. What we are doing, we have two use cases. One is that you have an on-prem scenario. That means what will you do in the on-prem for the storage? You might have a file server. This is a file server. And the storage, I told you there are different storage types you can use. There's a network attached storage, NAS, and there is also a storage area network, SAN storage, right? There are different types. We can't go in detail about what the storage types are. Just imagine that you have a storage. It will be again, physically it looks like a server, but it will be a storage unit with different multiple hard drives installed on it. Okay, these are nothing but drives. So these drives combined, it will be used as a storage unit in your on-prem scenario, and that can be attached to your server. This is your file server. This is the storage. So through the file server, you will create the network shares. For example, this is your file server. The file server name is FS1 example. So if it is a Windows server, when on the file server on the FS1, you will create a folder data. Just an example. You might create different folders for different departments, department wise, and those and assign these appropriate permissions for each folder for specific department users. So let's say I'm having this as a file server, which is having the storage assigned to it, and then I'm sharing this storage from my file server, creating a file share. So what will happen on the server? You will see you have a C drive local, which is with the local hard drive where you will be running the operating system. And the storage which you're attaching, you can create another drive, let's say E drive, for storing the data. Okay, this is basically the storage on the storage unit, not on your file server locally. And you will be sharing this. So when you share this as a user, how I can access this? Uh, let's say this is the user. So users can access this by typing / of server name / data. So this is the file share. It's called UNC path. UNC path in the networking and the system technology. So this is how you can access the file share. So basically, as a user, you're using this file share where you're storing all your work related data, and that data is actually hosted in the storage through your file server. It is going to the storage. You're just managing access to that storage through your file server. This is a typical scenario of having the storage in your on-prem setup. Now, your company in the lab, you're exploring two options. What are those two options? One option is that you want to use cheaper storage for the files which are not frequently accessed, right? That's the first requirement. The second requirement is that you want to also consider using Azure storage for the file shares. So how you can do that? Instead of using this storage, I don't want to maintain this storage. There's a lot of maintenance cost, maintenance overhead for the company. So what you can do is, if you want to replace this, you can go ahead and use the Azure Storage account as a file server. So in the background, what will happen is, let's say you have your Azure environment and you're just buying a storage. Now remember this, you can are you able to see the screen? It is too big.
Yes, sir. When you writing the dashboard, the back that side
Okay,
where we
one
can't
second.
see.
Yeah. Let me see.
You can
I don't
zoom
know why
out,
it
you
is.
can see actually some those who
Yeah,
are
yeah.
not able to see
I'm
it.
yeah. This is the problem with the whiteboard within Teams app.
Members can zoom out. Members can zoom out.
Members can zoom out. Really? You can
Yes.
do that?
Yeah.
Yeah. So try to do that, Sujani. If you can zoom out and see if you're able to see the full board. There's a zoom option down on the right side, right?
Control scroll
Yes,
up
yes,
and
exactly.
down.
So if you zoom out, you're able to see the full screen. So you can
Y-
control that from your side, right?
Yes, yes, we can.
Yeah. So I've explained you an on-prem scenario where you have a file server and a storage unit, and you're using for storing the files for your local users. And now your company wants you to explore the Azure storage option, one for the non-frequently accessed files, so that the storage cost reduces. And secondly, you also want to consider Azure storage for the file share. How we can do that? Let me tell you. So what I was telling you is this: you can use the Azure infrastructure as a service model only for the storage as well. It's not mandatory that when you build the virtual machines and use the Azure resources. You don't need the virtual machine in this scenario, particularly. You don't need to build the virtual machines. You can simply create the Azure storage account and use that as a storage for your file server, which is on-prem. Okay. So how we can do that? I'll just quickly explain you. So on Azure, what we're doing is we're creating the storage account, and in the storage account, I'll create a file share. We'll see how we can do that. Uh, Azure file share. So this account, so Azure is basically the public service, right? It's a public cloud. That means it is publicly available over the internet. I would request you guys to move your cursors, like Ahmed and Sharon as well, so that it doesn't hide the stuff. Yes,
No,
you
it
still
doesn't
have
hide.
to.
I can scroll and see,
You can move,
so I can
right?
follow you. Yes, I can
Okay,
move, so I can
all
follow
right,
you.
fine. So yes, so this is a public service wherein you are creating the storage account, and this storage account will be available over the internet. So now this you are creating a storage account for your own organization, which is available and accessible over the internet with the help of URL. It will generate a URI or the URL. There's a difference between the URL and URL. I'll explain you that later. But just remember that you can access the storage with the HTTPS access with the storage account name, storage account followed by the domain name. So you can do that. So now I have created the storage account. In order to get rid of my storage locally on my on-prem scenario, I will first of all create the storage on Azure, and I'll transfer all the data from my storage to the storage account in the Azure. So let's say this is my storage account. I will migrate the data here. And once the data is migrated, I will link my file server to the storage account. We'll see how we can do that. And then share the file storage. They still have the same concept. You can still create the file share on your file server, and it won't be visible to the user. The user will not see the difference. So in the background, what you're doing is you're getting rid of your local storage, the storage completely. You're moving the data to Azure storage, and you're linking your file server to the Azure storage and creating the similar access method for your users. So this is what we are going to do in this exercise, right? So let's. I hope this is clear. We can and we can do the lab. If you have any question, you can ask right now. Okay, so let's see. So here in this exercise, we are doing two things. Task one is we are creating the storage account, and task 2 and 3. In task 2, we are creating blob container wherein we can directly access the storage over the internet and save the files, whatever type of files we want to save. In task 3, we are creating a file share, which we can link and attach it with our file server locally, or you can even directly access the file share over the internet. So these are the two things we are doing. So create and configure storage account in the task one, create and configure secure blob storage, create and configure secure Azure file storage. Okay, in this task, we'll create and configure storage account. The storage account will use geo redundant storage and will not have public access. Will not have public access. Okay. Why we are not doing public access? Let's see. Let's carry on and see what we are trying to do here. All right. So I hope you don't have any difficulty following the labs. Uh, I'm switching between two different windows very frequently. This is our Azure portal, and this is our lab which we are following. So now I'm going to look for storage accounts. Storage account. And again, just creating the storage account will not cost you anything unless you start saving or storing the data on it. Create a storage account, blade opens. Yeah, here we are actually now. Let's start creating the storage. Create. Click on the create. Again, you have some mandatory fields to choose, like subscription and the resource group. We are using this resource group for our labs. And here you have to give the storage name, account name. Name of the subscription, resource group, storage account name, any globally unique name. Now, since this storage account is accessible over the internet, the name of the account has to be unique. There cannot be two storage accounts with the same name because this has to be accessed over the internet. So now we'll give some name. I'll give the name my storage in Azure. Right, so it will do a quick check whether this name is available or not. We'll carry on with this. East US is the region. Performance, we are going to select the standard. Notice the premium options. So this is one of the option while creating storage. East US performance, you have standard. Recommended for most scenarios. General purpose V2 account, which we'll see in later advanced classes what does this mean. Premium recommended for scenarios that require a low latency. That means if you're using the storage for big data, which requires very fast access to the data, retrieving the data, you can go with this premier option. So we are going with the standard redundancy. We are going with geo redundant storage, and we'll again notice the options here. So default is geo redundant storage. You can see there are different options as I explained you. This is all about the replication, the copies of your data, how it is going to maintain. So in GRS, intermediate option with failover capabilities in a secondary region. So it maintains the copy of your data in the secondary region, right? So we are going to use GRS. Make read access to data available in the event of regional unavailability. Check the box. Okay, that's already checked. So in this case, when you're going GRS as a redundancy option, if your primary region, which is where you're creating the storage, is US, if this is down, then it is telling you that your data will be available for read access in the secondary region. Okay, next. And here there's a note, you should use the standard performance tier for most applications. Use the premium storage tier for enterprise or high performance applications. That's fine. On the advanced tab, so we're going to the advanced tab now. Okay, we're in the advanced tab. Use the informational icons to learn more about the choices. Take the defaults. So we're just going to take the defaults for now. We're not changing anything here. Okay. And here you can see actually the storage type which you're creating, whether it is going to be hot access tier, cool or cold, which we can change even later after creating the storage account. But we are not doing anything on that level for now. We're going to the next level and the networking tab. In the public network access section, select disable. So in the public network access, we are selecting disable. That means it restricts inbound access while allowing outbound access. So it restricts access. You can't access the storage. We'll see why it is doing that. Review the data protection tab. We're going to the data protection tab now. And in this tab, what we are doing, tab notice 7 days. 7 days is the default soft delete retention policy. Note you can enable versioning for blobs. Accept the default for now, but it is telling you that there is an option here, enable soft delete for blobs. Soft delete enables you to recover blobs that were previously marked for deletion. That means it's like a recycle bin. So your data which you delete from the blob, it is stored, it is available in the bin for 7 days, from where you can retrieve the data back. Then we are going to the encryption tab. In the encryption tab, notice the additional security options, accept the default. We are going to use the default options here. As I told you, we can have Microsoft managed keys or customer managed keys. For high sensitive data, you might want to go with customer managed keys, wherein you know that only you have access. Now, not even Microsoft will have access to the data. So enable, okay, so we are going to select defaults. We'll continue with this next. And here we are going to review and create it. So that's all about creating the storage account. We'll create. Now, after creating the account, we are going to the store resource. Okay, let's quickly see what is next. Okay, it's still going on. It might take a few more minutes. My credit is going down. Maybe some VMs are running. Let's see if there are any VMs. Oh, yes, I have these VMs running. Let me stop these VMs. Are there any other VMs? Let's quickly see. That's stopped already. Okay, that's right. Now let's go to our storage. Go to the source. Okay, that's my name of the storage, my storage in Azure. So now what we're going to do is overview blade and the additional configuration that can be changed. There are global settings for the storage account. Notice the storage account can be used for blob containers, file shares, queues, and tables. So we have 4 options here for the data storage. As we have seen, the storage account, we can create a container, blob container. We can use it as a file share. We can use it for queues and tables. So we in this example, we are seeing blob container and the file shares. Queues and tables will be mostly used by the applications in the development scenarios. You might use this, but here we are discussing the first 2 types. In the security networking plus networking blade, we'll go to that. Select networking. So in the security plus networking, click on networking. Notice public network access is disabled, right? So public network access is disabled, right? This is what it says. Now select manage and change public network access settings to enable. Click on manage. And we are going to enable the access. So what does it do? Allow inbound and outbound access with the option to restrict select inbound access using resources access configuration for this resource. So we'll understand that in practically instead of reading it through. So we are now enabling the access. Earlier, what we did, we just created the storage and we disabled the access. That means you have a virtual machine created and you remove the public IP, and that means you can't even log into that virtual machine and set it up. So similarly, we created the storage account, we disable the access, and we can't do anything about it. We can't use it for storing the files or accessing the files. So now we are going back and enabling that access. And now change. Okay, so change the public network access scope to enable for network from selected networks. So what we are doing is now enable from all networks. That's the default setting. That means anyone over the internet can access this storage, but we are changing it to selected networks, enable from selected networks. And then in the IPv4 address section, add your client IPv4 address. So which client IP we are going to add here? Okay, so this will be my IP. Let's see what is my IP today. That's the public IP which you need to add here. If it is your organization internet connection, I guess it is still the same like what we had yesterday. So this is my public IPv4 address. If I restart my network internet router now, it might change. So I'm specifying here my IP address, and I want to enable access only from this and save it. In the data management blade, select redundancy. Data management blade. Where is data management blade? Yes. In here, we are going to select redundancy. All right. Notice the information about your primary and secondary data center locations. Right. So here it shows you, since we selected the geo redundant, right? Geo redundant storage. It is showing you here. Your primary region is East US, and the secondary region is West US. This is done automatically in the back, behind the scene. We have not selected West US as our secondary region. Microsoft does it automatically, right? And you can see in the map the distance between these two regions, Azure regions. This is the east and this is the west. Both are and starting point of the country and the end point of the country here in east-west scenario. In the data management blade, select lifecycle management. In the same blade, we are going to the lifecycle management. Okay, and select add a rule. Now we are adding a rule here. Name of the rule, move to cool. There's a name we are going to give. Notice your options for limiting the scope of the rule. Click next. Apply the rule to all blobs in your storage account. Limit blobs with filters. So this rule you can apply for a specific folder in your storage or for the whole storage. So we are actually creating a rule for moving the files which are not frequently accessed to a cool storage, right? So in order to reduce the cost for the storage account. On the add rule page, if base blobs were last modified more than 30 days. So where is that option here? I think it's on the next page. Yes. Base blobs were last modified more than 30 days. Okay, that means if the files are not modified for last 30 days, then what to do with that? Move to cool storage. Okay, move to the cool storage. Where's the option? Move to cool storage. Right? Okay, there are other options which you should notice. You have option to move it to the cold storage or archive storage or even delete the blob. Here in this exercise, we are moving it to the cold storage. So this is a very good hygiene practice on the storage, because usually what happens is when you're storing data, some companies might have 10 years of data stored in the storage, which is no longer actually relatable to your business. It's of no use. Neither your compliance or audit requires for you to maintain 10 years of data, and now the business needs it anymore. So you can get rid of the data automatically setting these rules up. Notice you can configure other conditions. Select add, and when you're done exploring, okay, that's fine. Add. So we have created a lifecycle management rule on our storage account. Now create and configure secure blob storage. In this task, you will create a blob container and upload an image. Blob containers are directly like structures that store unstructured data. Okay, we know that. Now let's go to data storage and the containers. And we are going to create a container. Until now, whatever we have done on the storage, there's no way we can store the data on the storage. We can't make use of it. We have just sent we've done some basic settings how this storage should be accessible and what are the rules for the data storage. And now we are going to create actual container where we can store the data. I name it data as per this. And notice the access level is set to private, public access level, anonymous access level. You don't have an option to change it. Private, no anonymous access. That means not everyone over the internet can access it. So why it is done? The access level is set to private because anonymous access is disabled on the storage account. That's the default setting. Okay, on your container, scroll down this and select access policy. Where is this? Are we going to just create this? Let's see this first. We have noticed this one, right? And on your container, scroll to the ellipsis. On the far right, select access policy. Let's create this one. Yeah. So our container is created. Okay. So you can see this is the data container I've created. Access policy. Now here on this container, we have access policy. So I'm clicking on access policy. So you notice there are discrepancies in the lab steps. So you really have to get onto the portal and do it yourself. Then you will understand where is what and what options are available. We are now clicking on access policy. In the immutable blob storage area, select add policy. Immutable blob storage. And here we are adding the policy, access policy. And in this policy type, we are saying time-based retention. Policy type is going to be time-based retention. Set retention period for 180 days. 180 days. Okay. And click save. Okay, we have set the retention policy for this storage account. Click save. Next, continue. Manage blob uploads. Return to the container page and select your data container. That's the container. And then upload upload blob plate, expand section, and the upload. Locate a file to upload. This can be any type of file. Now we are going to actually upload any file from our system. I'm going to upload, for example, I don't have any files here, which I can upload. Maybe some images. Let me see. Let's upload this image. Okay. Browse for files. Select advanced. Select advanced. Blob type. Blob. That's a blob type. Block size 4 megabits. That's the default size. Encryption scope. Okay. Upload to folder security test. So upload to a folder. So it might create a folder in our storage. Encryption scope, use existing default container scope. Existing default containers. We have not set any encryption right now, and we are going to upload, I guess. Yes. So what are we doing? We have created a storage container, blob storage container, and in that storage we have uploaded a file. So you see that in your storage account, you have a folder created, security test, and there's a file stored which I have uploaded from my machine. Confirm you have a new folder. Yes, the file is uploaded. Select your uploaded file. Click review and review the file. Click here, review. What is that? Review or view or review? Review the places option including download, delete. Okay, just asking you to check this option: download, delete, change tier, acquired list. So there are different options to do this. You can download this file, you can view this file, and you can edit and view as well. We'll see. This is the file I have uploaded. Copy the URL settings. Okay, now we'll go to that file again. URL, copy URL, and paste into a private browser. Okay, for example. So it is asking you to access this from the in private mode. And you can see that public access is not permitted on this storage account. Okay, this is the message we get. It should be presented with the XML formatted. Yes, it is saying public access not permitted. So configure limited access with blob storage. Now we are going to, we have uploaded the file. We have created storage. We uploaded a file. And this exercise seems to be little more left. If you want to continue, it's already 2. It's up to you if you want to see all the steps. And if you want to quit, you're free to quit. This is being recorded anyway, you can see it later. So I'll just finish this lab and end the session here. So we are going to configure the limited access now. Browse back to the file that you uploaded and then select generate SAS and specify the following settings. So I'm going to the file back and generate SAS. What is SAS? Shared access signature is a URI that grants restricted access to the Azure Storage blob. So this file is referring as a blob. That's what you need to understand. Don't get confused with the letters here with the terms blob. So it is nothing but a file. So you're enabling a very limited access on this file. Use it when you want to grant access to storage account resource for a specific time range without sharing your storage account key. So you want to enable access to this file for someone to access it with a time-based access. So what we are doing is signing key is key 1. Signing key is key 1 here. Permission is the read permission. Notice your other choices. So here we are going to give read permission. Okay, and then you have start date is yesterday's date. Today's let's keep this as yesterday date. And expiry start time is current time. Yesterday's date and the current time. Okay, expiry date is tomorrow date. Okay, and expiry time is the current time. That's fine. Allowed IP addresses, leave blank. Allowed IP addresses, we are going to leave it blank and click generate the SAS token. So it creates the SAS token, Bob SAS URL. So what are we doing now? Next, copy blob SAS URL entry to the clipboard. So, blob SAS URL to the clipboard. Okay, I copied it. Open another window. Okay, we are going to open the incognito mode again, and I guess we are going to paste it, and we are able to access the file. This is a temporary access we have enabled for this file to be accessible for this date and time. It will be accessible until tomorrow this time, right? So next, what do we have next? Let's carry on with our lab. You should be able to view the content of the file. Yes, I'm able to view. Now, this is the last task, I believe. Create and configure an Azure file storage. In this task, you will create and configure file shares. You will use storage browser to manage the file shares. Okay, create file share and upload the file. In Azure portal, navigate to the storage, data storage, your storage account. In the storage account, data storage, we are going to the data storage. This is my storage account and data storage. In the data storage, I'm going to the file shares. I'm going to the file share here. In the file share, click on the click plus file shares, right? Yes, baby. Right. File share, click on the basic tab. On the basic tab, we are going to give it name share 1. All right. Notice the access tier. Access tier is transaction optimized. That's selected already. Then move to backup tab. Backup tab. Click on the backup tab and ensure enable backup is not checked. So we are not enabling the backup. We are disabling backup to simplify the lab configuration. That's fine. And now we are going to review and create. So we are creating a file share similar to a file share on our file server on the Azure Storage account. right? This is created, I guess. And then explore storage browser and upload a file. Return to your storage account, select storage browser. We'll return to the storage account. And here you have something called storage browser. And this is the storage browser. Okay, and the storage browser, view all the storage services under your storage browser, select the file share. Okay, we are going to select the file share here and verify share one directory is present. And we have a file share which we created is present here. And the file share directory, notice you have plus add directory. You can add the files here, add directory. You can create a folder. So you can basically, let's say, create a folder structure. Like in your file server, you will have a folder structure created based on the department or different functions. Select upload browser, browse and upload a file. So we'll do that. We'll just create a folder called data. And in this folder, I'm going to upload a file again. Let's upload a file into this file. Okay, this file will be stored. Now you can view the file shares and manage those shares in the storage browser. Okay, we'll see that. Once it is uploaded, you can see that we have a file share created, share one, and that we have a folder created data, and there's a file in this folder. So we can see this file. What is the file? You have again access restrictions. We'll see that. We'll enable the access later. So let's continue the lab. Right. Restrict access to the storage account. In the portal, we are going to the network, virtual network. Okay, which network we are using for our storage account? You have to see that. So we'll have to see which network we are using on the storage account. Okay, we'll do one thing. We'll stop here and we'll continue to see file shares in the next session. And again, as you see that it's important that you do the exercises yourself so that you understand where is what option available, and you can replicate the scenario and the requirement what you have. So storage is still left. We have many things to do in the storage. We still have to see how we can access that file share, how we can map it to the file server and make it available to the users in on-prem scenario. So all of those we'll see later. Thank you for being with me for today, and we'll continue our class next week. If you have any questions, please let me know, or else you are free to leave and continue.
Excuse me, sir.
Yes, go ahead.
Thank you.
When I was creating an lab 3 practice one, I'm having doubts, sir.
Yeah, sure, go ahead.
Yeah. Can I share my?
Yeah, definitely. So those who want to quit, you're free to quit. We are done for today's session.
Can you give me the access for sharing, sir?
1 second, Shirin. second. I have not given the permission yet.
Yes. Sir, is it okay? The time is extending. Our next class, can we see, sir?
It's up to you. I can say for you, just to check this, if it is a quick one.
Okay, sir. You can check, sir. Before in the, I will show. I will share the Azure portal. Can you
Okay,
please give me?
yeah, I gave you the presenter permission now. Let me stop the sharing, the screen, the recording basically.